Good day. Hello. I'm still trying to figure out a few things. I am not too sure how to do some things. There we are. What board do we have then? MSI X570, I think it is. I need to still adjust the stream title. Gaming Plus, this X570? Yeah, MPG X570. MSI MPG X570 Gaming Plus Repair. There we are. Let's save that. Hi JFix, nice to see you here. I am just trying Green Screen Explorer. Hello there. Um, hello there, Daniel. This should be fun to buy them at work. Good luck at work. Don't let anyone see that you're watching here. Uh, Good day, man. Wickman, sir. Hello. Sergei Ridenko. Hello, glad to see you on, man. Hello, then. Privet. So, okay, I think I'm all set up. I think we can actually start here. Oh, how is everyone doing? Greetings from Freiburg. Hallo, Tobi. Schön, dich zu sehen. Hello there. So, let's have a good look. So, an X570 mainboard from MSI. I know that I had done work to this before. And what has happened is that I didn't have V-Core on this board. And I remember some missing components on the backside that I've resoldered but didn't get any change. So let's have a look at that again with the microscope then. So let's see. So let's see. Let's go to our microscope here. And I've been doing work somewhere around here. Exactly. There was knocked off components here. And obviously I didn't clean up. Great. Let's heat that up a little bit and clean that up. Where's my YouTube chat gone? There we are. Crazy how many boards get physical damage. Yeah, physical damage is like one of the main reasons why ATX boards fail. It's like, if I would have to say a percentage, I would say it's probably around at least half, like 50 to 60%, I think, of the boards that I get are just damaged by the customer itself. Like, it happens so quickly. And especially with ATX boards, people struggle so much to get them into cases properly. And there are so many points where they can damage things, like around the edges of board, on the backside of boards, and when they plug in GPUs. Like with the whole thing of GPUs getting heavier and heavier and bigger. I've made a video in the past where where I've shown how people damage like boards with their big graphics card near the SIO and knock off components from there. Okay. So yeah, that capacitor was ripped off of here, and all I did is solder to there and to there, just like it is probably arranged here and here. This is how it's supposed to look like. So the capacitor is attaching to this line, then on the other side it's just attaching to the resistor. And the same I've done here, drawn some from this line into there, and then from there connecting to there. Interesting that there are 3.3 ohm resistors here, but there are 2.2 ohm resistors here. These also have 2.2 ohms. Interesting, okay. Hello, Andy. Sir is transferring his streamers to you. Oh, oh, thank you very much. Is that's basically raiding, huh? He's trying, but you don't have the option. Oh, yeah, I might not have that turned on. This is like the third live stream. I haven't figured out any of my options. I'm very sorry. I might have to look into that in the future, how to enable raiding or however it's called on YouTube. I fixed that motherboard with CPU socket band pit. Yeah, I've seen that. You done it with um PCD Repair, I think he's called, or something like that. Very sorry for butchering the name, but I've seen that, yeah. The B550A Pro that killed two CPs is still working fine today. Thanks again, mainboard. Very happy to hear that. Very sorry for the CPUs, but yeah, taking 5 volts into 1.8 volts, the CPUs don't like that. And would you believe it? I just had that exact same buck converter have failed in one of my previous videos, and in the exact same way. 5 volts shorting to 1.8 volts. It is the MP2147, I think that buck converter is called. Seems to be a common problem on them. Nice live repair. Thank you very much. Thank you for being here. So, okay. The area looks fine. It is weird that these have 3.3 ohm resistors, and I've definitely also replaced this component right here. The IOR 3598. Are the others the same? Let's see here. $3598, yeah. It is the exact same one. And is the orientation the same? Dot top right, yeah. Pin 1. Okay, so I don't think there's any problems here anywhere. Let's see for these resistors, because there was physical damage here. Let's see for if they actually have the resistance that I supposed to have. Hey, Russ. Very nice to see you. I've been in your live stream yesterday. I haven't talked anything, but was there. Chris F in the UK. Hello there. So, let's see. We have a 0 ohm here. Is the software working? Please tell me the software is working. Yeah, it is. 0 ohm is good. Then 3.3 ohm resistor here. That also looks good. No shorts between there and there. And this 3.3 ohm. Also looking good. And the 0 ohm right here. Also looking good. Okay. So nothing here is shorted. None of here is damaged. So I've seem to have done this repair properly back in the day. Let's see. I think we will start this up and see for its behavior, what it will actually do. And I might have to look around for more physical damage, because if there's one place damaged, there can very likely be also other places damaged. But if I remember correctly, I didn't have VCore on this board. And that was what I was actually chasing. Oh, these capacitors look awful here. Someone went down on these screws. Very well. Okay. Thanks, I appreciate it, Log. Thank you, Russ. I always enjoy it. I saw you reball. I think it was on an Xbox. You were reballing the RAM, and you were doing the reball by hand. And that is something I've done as well. And man, that takes a lot of time. Reballing by hand every single one. Whew, that is quite the repair. I've done it on an X570, I think it was, or 580 back in the days when mining was a big thing. One of the first things I was trying is repairing a GPU with artifacting, and I reballed that chip I think 3 times, and it never worked. And then I destroyed the board. I ripped off pads of the board and just rendered that thing useless. I still have that thing, I think, as a donor board for parts, but I completely killed it. At some point, I shorted to 1.8 volts also, and killed the core as well. That was awful. Like, man, I still need to learn how to reball properly with paste and with solder balls. But on ATX repairs, you very rarely have to do any reballing. Like, there's some PCH work involved, but the big problem is you cannot get any PCHs, and yeah, I haven't gone into that too much. But I definitely have to. This year I'm building my own BGA station. I've already gotten the big preheater, and now I have to do some work on getting a controller, getting relays set up, getting the top heater, and then doing some reflow profiles, and then also doing like I don't know how exactly it was called, some PID tune I think it was called. I also want to do that, and yeah, so I definitely want to get into BGA work, especially also for sockets, but I haven't gotten around to that yet. I really wanted to do some more streams as well, but I was caught up in exams for university, and basically from the start of the year I haven't done anything else but to learn for my exams in university. But they are mostly done by now, and now I've gotten some time, and I was like, I really wanted to get into streaming again and do some live streams. Just hang out a little bit, see if I can repair some stuff live. But otherwise, the board looks very fine. So I've been looking around, but it doesn't seem to be any damage anywhere. Socket change would be good content to see. Yeah, it's actually pretty interesting, but the first few videos would probably just be a lot of failing for socket repairs and learning. But maybe that would be interesting to some viewers as well. But the interesting part is, all of my videos where I failed repairs always had a lot worse views and dislike to like ratio. When do we get to buy memberships? I don't offer any memberships, to be honest. And someone has asked me recently for a PayPal link as well. They wanted to donate to me, and I'm like, nah, I'm good, thank you. Like, this is just a hobby on the side for me. Like, I'm not looking for any financial gain or anything. Like, most people don't know this, don't tell anyone. But all of the repairs I've ever done for viewers on my channel, which is basically almost all of my boards, they were all for free. I've never charged anyone for any of my repairs. All they had to pay is for shipping. Most of the time, I also paid for the parts, or like took the parts for myself. But don't tell anyone. Oh, this board has been in storage for me for like a year, I think. And I still haven't gotten around to repair it yet. But so far, it all looks fine. Like, no physical damage anywhere. Hi there, Linsteiner. We probably have to power this on and see, like, what voltages are there and what state the board is in. But I want to make sure that there's no physical damage. A lot of thermal paste around here, but this shouldn't affect anything. But looking good. Oh, that one resistor looks a little bit damaged, but I think it should be fine. Let's see if I get an ohms reading off of that. You're going to get a lot of repairs now. The world knows it's a free. I actually have mentioned that in a live stream before, and luckily I didn't get too many people. Okay, this is probably just a 0 ohm or something like that. Okay. Get some cash for your talent. I wouldn't call it talent. I just put a lot of work into this. And yeah. Oh, I took the BIOS chip off of here. Oh. We will have to put another BIOS chip onto here. What I've done here. Wow. Okay. I definitely have to get the new BIOS chip onto here first before we can do anything. I didn't even remember that at any point I took the BIOS chip for here for donors. But we will have to find out which one is supposed to be there and then put one in and program. Because we won't get far without a BIOS chip. But we might still be able to check for some voltages, even without a BIOS chip. AliExpress doesn't seem to have any leaded solder. Where do you get yours? That is a very interesting case of if you, in Germany, you're actually not allowed to get leaded solder because it's prohibited. And if you actually search for leaded solder on AliExpress, I also wasn't able to find some. But if you search for this mechanic solder, this is the model number HXT100, you can actually still get some. Or like that. I actually ordered this, and this is the usual 6337, and I was able to order it. So if anything, look for HXT100 from Mechanic and try to order that. That has worked for me. Let's see. Let's see if we find anything else here. Now around the audio I see, but the audio I see doesn't really matter. The SIO is where it gets interesting here. If we can find anything here. But the SIO looks fine. Nothing obvious around here. Let's see at the edge of the board. Also nothing, okay. I'm really interested how this will react if I try to like start this without a BIOS chip on there. Like what the power consumption is, what the voltages will actually start up when I do that. The board is dirty, but nothing actually damaged. Except this, oh yeah, I remember. The USB 3.0 has a broken housing. Yeah, right, there was something. But that doesn't affect anything for us. So yeah, I think we go to the overhead, plug a CPU into here, and see how it reacts. If not, we will have to see for the board view for this, check out which BIOS chip I actually need and solder, program BIOS chip and solder it onto here. Because otherwise I couldn't see anything so far. So let's go to the overhead once more. There's the other scene that I need. Let's see. Okay. We do our usual 2200G then. I'm actually interested in if this will react to a power button without a without a BIOS chip on here. So RAM, CPU. Let's get a button onto here. Power consumption, power supply. So let's see. Software is connected, 130 milliamps. That actually looks really good. That looks like pretty much all of the voltages are running. Let's see. So let's see. Do we have VDDP here? Nothing here. Another inductor, might be 2.5 volts. 1.8 volts. Yeah, 1.8 volts is present. 2.5 volts, I think. Not there. 5 volt dual. 5 volt dual is there. Interesting question. Where's VDDP on here? Because I feel like the VDDP is missing. It might have a standby VDDP in S5 that is created by something else, but I cannot seem to see that. Because if you have a look, there's usually the VDDP is somewhere around here, this area. Please focus camera. There we are. Usually it's around here. And if you have any inductors like this one, you would want to check those. But this inductor, for example, is dead. There's nothing on it. And there's other inductors right here. This was the 1.8 right here. And then there's this one right there, which is probably 2.5 volts VPP. And that means this is probably our VPP that isn't running. But VPP should be present in standby in S5 mode. But it isn't. We might want to have a look around here why that is. but it also could be that it has two different VDDP lines, like one in S5 state, where it always produces that, and one in S0 state, where if the 12 volts from the power supply comes in, it takes the 12 volts and then produces a stronger VDDP that is capable of more current. And that might be the thing here, that the VDDP is actually created somewhere else in standby mode. But we will have to probably figure that out with a board view. Let's see if it reacts actually to the power button. And it does. 2.2 amps. That actually looks very good. Let's see right here. We do have VCore. 1.1 volts. Okay, so VCore is present. Let's see if the 0.9 is then... Yeah, the 0.9 is then present here. 1.8 volts present. CPU's getting a little bit warm. Yeah, we just don't have a BIOS chip, so probably just a BIOS chip. 2.5 volts VPP also present. Okay then. Let's get a BIOS chip. Let's see what version for board view we actually need for this. Let's see. Microscope. We need the version MS7C37 version 2.1. Okay, let's switch over and let's see for the board view. I also got some low melt solder for harder to remove components. Works wonders. I actually have some bismuth solder here, I think it's called. That should also be like 150 degrees. I haven't tried it out yet, but it should be pretty good for that. So let's switch scenes. Let's get our board view files, schematics. This is an X570. X570, and it was 7C37 and version 2.1. So in the board view, yeah, this is VDDP. The switch. Okay, let's see. VDDP. Does it have a VDDP S5 or something like that? Because I was curious about that. Yeah, VDDP S5. Where is it derived from? Because I want to know. Oh, there's a controller on the backside. Okay. So there's a controller on the backside that creates the VDDP in standby mode. And that is why I didn't find it. Interesting. But there's a pro point for it. Okay. Okay, well, let's see for the BIOS chip. We need a Windbond W5Q256JW. Okay, let me see. I should have those. 1.8 volt chip 256. This one, I think. Let's see. There are the two different footprints. There's the small one and the bigger one. JWIQT. JWPIQ I have here. Let's go on the microscope. I have two chips here. And we will have to see if those work. Because those both are used chips. I want to figure out if they are good or not. Because sometimes I throw chips into here where I really don't know if they're good or not. Oh, let's see. Yay, I made it. Lead farmer, hello there. Yeah, I don't, I will have to, I need to learn how to do like the announcement of streams. Because as far as I know, you can like announce that you go online. And yeah. So let's go to the microscope again. So let's see, I have two chips here. This one and this one. Both used, but they should still be fine. Let's see. Oh, this is an MX, I see. Oh, so this we won't use. Because it calls for Windbond chips, so let's not use that one. And this one is a Windbond chip. So let's see right here. Can I get... Yeah. 25Q256JW, and the board view said JW, right? Yeah, exactly that one. Okay, so this should be a fitting chip for us here. Nice, finally live stream. Hi. AMD's not too picky. Hi, Russ. Yeah, hi, JW, yeah, exactly. The JW is the 1.8 volts. So, let's see. Do we need to protect the area? I should protect that a little bit. But first, let's clean up a little bit, because the last time I've taken something off of here, I've left a big mess on it. Let's clean it up a little bit. And then see to protect the header. Oh yeah, removing old hardened flux. Great. So let's see. Let's get some heat introduced into here. That already looks a lot better. Still some glue left from like protective tape that I've used before, probably. I found a live one. What a surprise. Yeah, it is, I think, the third live stream I've ever done. I think it's the third. Not too sure. But yeah, it's rare that I live stream, but I do enjoy it. So that looks a lot better already. I find a bit of spit. I have to remove all plugs. Okay, let's see then. Pin 1. Is there a pin 1 marking? Yes, I can see a triangle at the top left. That is probably a pin 1 marking. And this also has the marking right there. So that looks good. Let's see. Let's get my protective cover here that I use to protect that. This all should be leaded solder at this point. So I don't think I need to put on any new one. But I might want to be sure. Let's be sure. Put some, mix this with leaded solder. So that it flows easier. If you mention bias on the live stream LED farm appears. Interesting. Is he a bias expert? Yeah, this is a very good question. Yeah, this was definitely not leaded solder. Yeah, good that we did that. But I need a little bit more heat. So let's take off some more from the middle. So that should be fine. IPA and strong blower works wonders. I still need to get one of those blowers. They have blown up recently. Like there's so many of them being sold. And yeah, I still haven't gotten around to get one. I actually have an air compressor here, like a big air compressor with like 10 bars. I could still, it is almost reachable by my bench. So yeah, I could just use that if anything. Yeah, a bit of a pro when it comes to BIOS then. Oh yeah, yeah, I do BIOS for many tags on Facebook groups. Oh, interesting. Nice, good to know. If I have a BIOS issue now, yeah, I also know where to ask. I don't know a lot of BIOS trees, but I get most interesting. I actually, Like, BIOSes on ATX boards are luckily really easy. Like, I've never had to remove a BIOS password or, like, do the, how is it called? The region thing, the ME region thing. That is almost never a thing that you have to do. And all of the BIOSes are readily available. The only thing that is a thing with ATX boards is like when they have TPM firmware or like a secondary like IC. EC chip or something like that. But other than that, like BIOS work on ATX motherboards is really easy, luckily. Oh, why do you jump? Get back here. There we are. Now we are in place. That's sorted very easily. 10 bars, the ball will fly away. Yeah, it is actually, like I said, it's a full-size compressor that I have here in my room. So let's clean this up. JFix Discord, I'm there. UEFI tool helps the map of contents. Yeah, UEFI tool is also what I'm using for like extracting TPU firmware from like ASUS boards, but that didn't always work. And also getting like the bin file out of the cap file from ASUS. Okay, we'll add your shit your nip clubhouse friends list. Could you give me the repair tip, please? I have a MSI Z490 motherboard and it's failing the RAM test, even though the RAM modules are fine. There are a lot of RAM voltages, different ones, and you will have to check if all of those are running. There's VDDQ 1.2 volts, there's 2.5 volts VPP, there's 0.65 volts VTT, there is, then there are data lines that you need to test, like the connection between the CPU and the DDR sockets. Yeah, there could be so many things that are wrong with, like, RAM. Yeah. No, I don't mind, or ping me in a few Discord repairs channels. Oh, okay. Could be CPU related. Yeah, it could be CPU related or to the connections to the CPU could be also related to that. Let's clean this up a little bit more. So let's get this flashed. Let me get my adapter that I use for MSI. Where is it? I haven't been flashing a BIOS in quite some time. Where's my MSI adapter? Where? There. Let's see. The MSI adapter that I have with pin 1 to the bottom left. Like that. Get the CPU out of here, get the RAM out of here, and let's go to the computer and try to flash this. So RAM compatibility, I find passes and mentors most times it fails during game crash. Expo VRAM, not all RAM are dual compatible. And beware of bad memory channel on the CPU. Yeah, that can also be a thing. I find JSPI pins sometimes need 24 power cord active to proper detect. Yeah, that happens. There are some of these pins for the JSPI header do get 1.8 volts and you will put on 1.8 volts into here, like through your BIOS programmer. But there's sometimes a transistor in between that disconnects this header from the actual BIOS chip, and then it won't work. That can happen. I've seen that happen. So let's see. Where did I put the programmer? Right there. Let's get the programmer software open and actually see. So let me get. So let's switch scenes. Is this the right one? No, that's not the right one. Let me see. I need not this one. This one. That's the one we need. There we are. So let's see. We need an MSI MPG X570. I'll just quickly getting the how's it called? The BIOS from the manufacturer's side. Schematics. I found the board. Let me quickly save this somewhere. Good explanation, thank you. No problem. Unfortunately, I only have CPU for testing SLRNG5905, and it works normally on a H410 board. Okay, yeah, that's good. But what can be, Igor, is the connection between the CPU and the RAM sockets. There can be a damage there. They can be partially damaged. Data lines, for example. Uh, I only tested with the data line tester. You can test them with like a multimeter, but that is such a big chore. Like, I wouldn't recommend doing that. Only like, yeah, I would get a tester for the data lines and then do it. So let's see. Does it recognize our board and our chip here? And it did recognize it instantly. That is very great. So let's open up what we need here. X570. Gaming Plus. Oh no, that was wrong. I just opened up the zip and I need to open it. I need to first unfold it off of here. Let me see. Oh yeah, open it up. Oh, yeah, I really need to re-download that. So let's get the actual BIOS file. So let's open this up. I did the same thing again. This, and this. Now we have the right BIOS file. So let's program this. Oh, and let's wait for it. Sounds voltage or CPU or chipset BUGA reflow. My memory is good. It works on my main computer and ASRock X470 Tai Chi. So likely chipset over volt wrong. The memory. So it could be the board still. I've had it that there are different compatibilities, especially as soon as you try to run XMP profiles or something like that. That some boards just don't like a specific CPU in combination with specific memory. Like, I've had a case where a CPU and RAM combo would work on like 3200 in one mainboard but wouldn't work in another mainboard. Like, the topology of the mainboard actually matters a lot for that, and you can get mismatches where that does not want to work properly. Like, RAM issues are so random. There can be so many things with them. Like, diagnosing RAM issues or having like boards that randomly turn off and on. Oh, I hate to repair those. Those having repairs like that is awful. Well, it would be. I've flashed several BIOS versions and the symptom remains the same. I think it must be PCH problem. It would be interesting to have like different RAM and different CPU combo on there to see if it also has a problem or not. But that would mean having another set of RAM and CPU, and yeah, who has that just laying around? By the way, on Intel CPU boards with global GBE LAN needs old serial transfer from backup. If doing a new BIOS, I extract as is from old. Yeah, I've had that happen on ASRock boards, on H110s. And the good thing of the serial should be on a sticker somewhere. So, so even if you don't do the actual, even if you delete the old BIOS or don't have access to the old BIOS, there most of the time is a sticker on the actual board where you can find that serial number. Really interested in this behavior of this board now, when the BIOS will be fine here. I'm also interested if this BIOS chip is good, but it's, oh yeah. I just said that. Yeah, I think I put a BIOS chip onto here that is trash. Because the how this works is it erases, and erasing actually means writing zeros everywhere. Then it actually writes the BIOS onto there, and then it does the verification. And the verification is the most important step. Um, because the verification actually sees if anything was written onto there. Erase chip, then verify blank. Yeah, we could also do that. Erase memory. Let's erase it. I download the BIOS directly from the MSI website. They're ready to be flashed. Yeah. That is not a problem. If you do it like within the BIOS itself, it automatically does all the stuff for you. Only if you do like the kind of flashing that we do right here, where you take a chip actually off of somewhere and then want to program it. Let me see if I have. Yeah, I think I have WinBond ICs here. Yeah, I'm just going to erase it, and after erasing, if I read it, it should be zeros everywhere. That's basically the same like doing blank checks. But we probably just have to throw that chip away, solder another one onto there, and flush it once more. So memory is erased. Let's read this chip. Thank God for this programmer. Like, I have used this programmer for like 2 years now, and I'm so thankful that it's so much faster. Oh, having the CH programmer, like, it does all what you need to do, but it does it so slow. Does this programmer have a blank check? It should probably have a blank check. Somewhere. Not too sure. I think you can do it in the settings where you can like put it that if you erase it, it also does a blank check, but you can just do it manually like this as well. Oh, actually going to 2 volts is a good, is interesting. So it does show that it's blank. But increasing to 2 volts or 2.1 volts is like actually a good point. Let's VPP. Yeah, let's do it like that. Let's do 2.1 volts, accept, read. And now, yeah, let's leave it at 2.1. Let's open this up once more and try this once more with 2.1 volts. Voltage is higher. Yes. Yes. So let's see if with more voltage this will actually work. Will be interesting. And if not, we're just going to throw a different chip onto here. Oh, sadly not too much I can show you here, guys, while flashing a BIOS. I'm also almost sure this chip is one you replaced 2 months ago video I saw. If you remember that, that's actually insane because I would not remember that even though I made that video, edited that video, and uploaded it. But interesting that I then threw it onto like my box of good or like in my box of BIOS chips. I usually don't like put bad things onto there. I remember Grandma's car when wow, okay. Props to you then. Can't really remember what I've eaten yesterday. I'm a dumber version of Rain Man. Well, it's going to be interesting when when it will try to verify here. If it fails, we're just going to replace the chip. Then the chip just goes into the trash. I was really thinking this repair to go another way because I remembered that this board didn't have V-core voltage, but yeah, just like we just saw that it definitely does have V-core voltage. Hmm. I do have quite some more boards to repair. So don't worry, we will never run out of any content here. I have so many spare boards and things to look over again, so yeah. I have the memory of a goldfish. Same, Russ. My wife all the times has to like, she like tells me something that she's going to do this week, and I'm like, you told me something you're going to do this week, but I cannot remember for the life of me what it was. She's always annoyed at me because she has to tell me like 2 or 3 times until I actually get it into my mind where she is and why she does comes home late and all of that stuff. CPU, vCore is sometimes CPU ID glitch. Yeah, actually, that can actually be disabled or enabled by the CPU ID. So programming will be done. Let's see. Nope, still fails. Okay, chip is dead. Well done. Let's go under the microscope and just replace it. Different scene, microscope scene. Oh, let's go over here again. So this chip is definitely toast. Let's see. Is this a windbond IC? This is the windbond IC, but this is the smaller footprint, I think. But I still think I can manage to put it onto there. And this is MXIC. Yeah, this is an MXIC. I still have another used MXIC. I might want to try that. Even the board, like, the board calls, or like the board view calls for Windbond chips, but I've seen like other chips work as well. So I might want to try this MXIC onto here as well, just to know if it works or not. Check the chip is 1.8 volts. Yeah. The chip is there. Oh, or if I have 1.8 volts at the circuit. I will first try the MXIC. If we run into the same issue with the MXIC, then I will definitely check if the voltage is there or not. But I'm just going to lay this one to the side for now. Going to take it off, put the MXIC onto there. Then I want to try to program the other chip. So chip is off. Let's get the MXIC into here. And MXIC is on here. Trick to find out if it works, flash it, then flash it with BIOS, GUI again. If it fails, doesn't accept it, it can boot, but it won't reflash via normal way. Well, the chip is blank, so you definitely won't be able to boot with this one. So the MXIC is on there. Let's clean up the hot flux while we still can. And see if this MXIC accepts any programming. Because if not, then I can rule out basically both of these chips and throw them away. I might actually also try to flash the Windpoint chip in a programmer, like not on a board, but just a adapter board by itself, and then see if it accepts that. Because there might be, I've had it before, where something with the connection between the header and the BIOS chip was bad, and that's why I couldn't program it. But yeah, everything here looks fine. So let's go over to the computer again and let's try to flash this. Back to here. Let's see if it recognizes the chip instantly. Let's see. Let's go for 1.8 volts again. And it recognized the chip. Let's take our BIOS and let's not read memory. Let's not do that. Let's open this again and let's flash it. What kind of programmer do you have, JSP? I made the cables myself to go onto the JSP or like the headers onto there. It's I just pinned it out and took a cable and soldered onto a connector. Revel Proc, I think it's called. Yeah, Revel Proc IS. Windbird chips have a built-in write protection feature. That is not true as far as I know. Yeah, programmer overrides it. Yeah, write protection. I think you mean OTP. Not all have that. So the MSI cable on AliExpress. I've actually also seen like adapter connectors on AliExpress, but I've never tried them. All of the connectors that I have I made myself. So I just soldered them up to a connector that fits onto the header, and that's all I've been doing. Very weird. The software sometimes behaves in a way where you don't have a progress bar on erasing. Like, I can see changing current, so it's definitely doing something, but the erasing doesn't have a progress bar. It probably still works. Like, most of the time that I had this, it still worked and did it fine. But yeah. Yeah, you can also do pin headers. Yeah. What I actually gotten, I've actually looked up how the connector is actually called that goes onto there to have like one solid connector. Uh, then put a cable onto there and then hot glue it, everything. One-time programming. Oh, so that thing is like fusible. So after a single programming, yeah, it shuts itself down. But how does that make sense with ATX BIOSes where it is basically designed to be flashed? 2.1.5, 1.5, yeah, the 1.5 pitch, yeah. You can use just the DuPont, but yeah, like I said, I just used an actual connector. Oh, a small area only is interesting. On Neo Programmer, I have to manually disable the write protection. Interesting. I think Neo Programmer was the one that I used at the beginning as well when I still used the CH. I think you have great potential in YouTube. Just keep in good work and go for more fancy boards. Try laptops, GPUs, challenging, but you're up to it. Thank you very much for the kind words. I actually gotta say, I have a job 20 hours a week and I'm still studying in university. I'm happy if I can get one video out a week. Like, I'm happy with what I have right now. YouTube is really just a side hobby for me. Yeah. Oh, it's verifying. That's very good to see. So it doesn't have to do anything with the board itself. It seemed to have really been the chip. JFix has done a lot past year for YouTube repair community. JFix is such a lovely person. He does so much for this repair community. He has such a big heart for all of the people getting into this. Like, he supports small creators in a really great way. Like, only love for JFix. He's great. So let's see. The content is actually onto the chip. Okay, now it gets interesting. So the chip has flashed properly. The other one is going straight into the trash. And now let's see if this board, how this will behave now. So let's dump this Windbond chip. Let's go over. We go to the overhead scene again. Let's clean up a little bit here. And let's actually get this built up and then see. These chips being write protected if you flash all the BIOS over irreversible latest BIOS. Oh, interesting. Chip will be unusable. Don't ask how I know. Interesting. I've wondered about that. Like, last week, or yeah, I think it was last week, I had a processor here. A9 or 88 series, something they are called. They are like a really weird version that you can use in AM4. And basically, every newer BIOS just deletes them for the compatibility for them. And I was wondering if I go back onto an older BIOS just to try them out, just to confirm if they are working or not. Good that I didn't do that. Most of the boards you still have from viewers or bought as non-working from eBay. Like, I think in the last year of making videos, 1.5 years, they have all been viewer boards, I think. Like this, for example, is a board that I have bought, I think, 2 years ago and still laying at my place. And this is one of the few exceptions of mine that are actually my boards. But almost all have been viewer boards. And I have so many boards from viewers, so many people that send me stuff and still have to work on. But I mostly do those for videos. The new Windborne 7XX chips are a pain. I've actually not accounted on those. Interesting. This like the one that is in here, the 1.8 volts 256 chip is the newest that I know. Like AM5 still uses these. Or do they use these or do they use the 512? No, I don't think I have seen a 512 yet on AM5. All I think are this size. So let's see. Passive power consumption. 130 milliamps. Okay, now I'm very interested in how this board behaves if we now try to boot this, I'm going to be so bold and plug an HDMI capture into here. So let's see. Let's press the power button. 3 amps, that looks very promising. 2.5 changing power consumption. Let me get a CPU fan into here. Oh, right. This had this error where it goes to a DRAM and a boot LED. Right. I remember this. It's hard to see. Let me get the cooler a little bit out of here. You can see solid DRAM and boot LED. And if I cycle it, it looks like a normal boot behavior, CPU, and then just jumps. Right, this was this problem. I totally forgot. I referred a German kid 2 weeks to you. He emailed me, my friend flashed the BIOS, but you crossed RGB pins bent and think 500 into the speed sense line. Oh, yeah, I've not heard of that. On your program has the option to edit SRE rec. One favorite electronics repair channel. Always great to see you live. Thank you very much. Great to hear that. And you have several settings inside. Okay. Oh, this issue. I've had this issue before that I fixed, but I think that was a broken component somewhere. I cannot recall what this could be. This issue for me seems like it goes into protection mode at some point. Like that there's some issue somewhere with like a vCore phase or something, and then it goes into protection mode, but it's this is so hard. What could this be? I want to try something. I want to see how this board behaves if we force the PS on by ourselves. If this is has the same behavior. Okay, it doesn't like that at all. Yeah, only 600 milliamps. It doesn't work on this board. I need to try a different CPU to see if it has the same behavior. Wie läuft das Business? Es ist alles gut, danke der Nachfrage. Einfach nur ein bisschen alte Boards reparieren, die ich rumliegen habe. Oh yeah, I plugged the CPU in while there's still power and it auto starts. But the same behavior. Let's get this BIOS battery off of here. Let's clear the CMOS just to be sure. Difficult board. Let's see. Let's try with this CPU now. This is a 2600. If it does behave the same CPU LED and the same boot and VGA. It's boot and VGA, not DRAM. Boot and VGA LED. Do you use a postcard sometimes? Yes, I do use postcards sometimes. I have two different ones. I have this one for DDR, and I have this one right here. We can see for that, but I don't really think there were going to be any postcodes. Because this doesn't really move into anything. Let's see. TPM header right there. Auto unlock just wouldn't work for me. Do you have a 3.3 volts on RAM? Why should there... Oh, you mean the SPD voltage. We can check that. Let's first do the postcodes and then check if we have SPD voltage. So let's see. Postcodes are actually running on the DRAM tester. And get stuck on 21. And now it's stuck on a CPU LED instead of a DRAM. And goes to AF. Nothing. And the postcard tester doesn't do anything in the TPM slot. Let's change the position of the DRAM. Get the DRAM onto there, and this one into here. Let's try that again. Still goes to 21 and done nothing. CPU LED and stuck 2.7 amps. Will be interesting if this gets stuck on a DRAM LED if I don't provide any RAM. Nice, I enjoy watching the videos even if you have no idea what you're talking about. I've actually had friends of mine look at my videos and say like, I use your videos to go to sleep because I don't really understand anything, but it's quite calming to watch. And I don't know how to feel about that. So let's get this voltage tester into here. And see if we have all of the voltages on there. So let's see. No, all of the voltages seem to be there. It's hard to see. SPD is present, VDDP is present, VTT is present, RST is low. Yeah. So we also do have 3.3 volts on the RAM. Let's see how this reacts if I try to turn this on without any RAM in it. If it then gets hung up on a RAM LED. Yeah, it just hangs on a DRAM LED. Sleep while surfing circuits. Current, I have a DDR3 motherboard repair. It boots with caps lock and numlock LED working, but no display even if GPU or built-in CPU graphics. Notice a consistent current consumption about 6 amps. Interesting, but the board has to be booted and the CPU has to be initialized for caps lock to work and still react. You definitely have a problem with capture then. I could say you try out all of the PCA that you have and try out one of these. Where is it? Try out one of these testers for mining that uses X1. These can help in order to recognize if there's any issues with PCIe. VRM section. Yeah, this might actually have a problem with the VRM section. I will probably have to take the coolers off and we will have to see for there. Rewrite BIOS forced. No idea what you mean with that. Not sure, but sometimes make it flow to fake it's on. I bet no postcodes. I actually have postcodes. Like the DDR tester actually showed postcodes. Yeah, BIOS was just written with programmer. Oh yeah, yeah, that was what you mean. Yeah, rewrite BIOS. Yeah, just rewrite. Force laboratory. Yeah, we just put a new BIOS onto there and a different chip. So we just been there. Yeah, let's take those coolers off and have a good look at the VRM section then. If we can see any more damage there, because like I said, I had damage there. So let's see. Let's zoom you out again. So let's get this cooler off of here. Number 1, number 2 are out. And time for some visual inspection going under the microscope. Let's see if we can find anything here. So far so good. Everything looking clean. Oh, you know what this might be? I've seen it before that these buttons go bad. And this constantly is in a reset state because of this button. We will have to check for that voltage also. Let's see, PWM controller. Looking fine. Is that like solder or something there? No. Interesting. It doesn't use a different kind of MOSFET here for like the don't know, don't have it in my head how the other voltage is called right now. Let's check if any of these MOSFETs are bad. So let's check from the 12 volts to ground, but it shouldn't have a fault there. But then I also want to see into the phases if I have anything there. So the 12 volts to ground has high resistance. Let's check 12 volts to CPU phase and to that other thing, to that other kind of phase. Also high resistance. Okay. So we don't have a short through there. I don't remember which streamer it was, but one of them said that the desktop motherboard repairs aren't worth it because they're cheap to buy new. What do you think? Yes. ATX motherboard repairs are not worth for money. They take way too much time, have way too many issues, and don't pay a lot and are mostly cheap. Only like top of the line boards are worth repairing because only they give you enough money, and there's just not enough work for top of the line boards out there. And yeah, if you're in for money, go for laptops, GPUs, phones, data recovery, something like that. VRM output is 1.4 volts consistent, doesn't go down. Almost not worth it. Bot is $180 lately. For curiosity, you should read about BIOS firmware protection on the data sheet. Oh, okay. This is unrelated, but do you have a plan to get infrared preheater to try some BGA work? Reballing CPU socket, chipset, and such. Your videos help me revive two dead motherboards. I actually have a full-sized BGA preheater here, or like IR preheater here. I mean, that is quite big. It's the INT883 that like full eATX boards fit onto there. And yes, I do want to do some work on that. And no, I haven't started on that. Still need to get around to it. Desk repurpose forced due to the age of CPUs no longer found on market. Find a 9th gen mobile hard. Yeah, especially Intel CPU. Like, I hate Intel boards because so many of them are just dead chipsets. Like, I've had it so many times. Like, I start a video, try to do a repair, and all I get is dead chipset. And I hate it. I absolutely despise it. So let's see for this button. Because I've seen it happen that these buttons go bad and they go like to a low resistance or to a resistance instead of open, where they force the board into a reset state. Let's see. How would I be going about this? I will need to find out which of these pins actually drag it down. And I think the voltage is probably going to be on that resistor then. And it should be constantly 3.3 volts. Might be on some of those. Let's go and check a board view. So in the board view, yep, chip reflows fixes 1 out of 5 temporary, sometimes with silicon degradation. Yeah. Spoiler alert, chipset's health is questionable. Yeah, it might be here. It might be. Under the mobile pins, press W with beep. Yeah, we could do that. But let's see. Flash active, this one. It comes to this with 5-volt dual. Yeah, only here. Where does it go as well? It only checks if this voltage goes low. Oh, how does it do it? On this capacitor, that's just ground. There's 5-volt dual here. What else does it do? Because it only does ground. How does it do it then? How is this? How is this right? How does it recognize anything here? Does it just monitor the 5-volt dual here? Because this board, it says the button has two connections, one ground and one flash active. Which makes sense. A button just connects two pins together. The one is ground, nothing to check there. The other one is this flash active. All it has... Oh, there it is. Oh, yeah, okay. I just missed that one connection. Never mind then. Yeah, there's a direct connection to this chip right here. Okay, so where we can check it on this resistor right here. If we can probe that to find out if this 5 volts is stable 5 volts or not. Does anyone know how to determine the faulty memory chip on RAM sticks? I've seen most people do it with thermal cameras with heat. Yeah, it goes to a chip around the PCIe slot. Yeah, exactly right. Yep. And yeah, well, let's then see if I can probe that place. Because I want to see if that is constant 5 volt or if anything there gives us problems and puts the board into a reset state. So microscope it is. So that is the oh, the capacitor is not even there. Interesting. Okay, let's see if I can probe this somehow. I will have to get my needle probes for this. But it probably wouldn't do that if the RAM... I'm just thinking about it. Would it? It probably isn't an issue because if you don't put RAM into there, this issue doesn't appear. And I would expect it to always appear, even if there's RAM or no RAM. Can you get a board view for a Z790 live mixer? No, I cannot. Like these very new boards, Z790s, there are almost none out there. Oh. Ich muss das wissen. Guckst du immer auf den Monitor für Mikroskope? Das ist auch. Nee, ich hab einen. I can say that for everyone. He just asked me if I always will look onto this screen or another screen, but this screen is blank. There's nothing on here. I'm using a TV that is connected to this screen, and yeah, that is where I'm looking to the top left. There's a big screen there that an actual TV that I hung up, and where I'm looking at all the time. You can use this screen, like no problem, but yeah, I'm using a bigger one. So let's see. So needle probes, voltage mode. Let's see right here. Let me get a ground attached to here. Somewhere where I can jam it into. Nothing to jam it into properly, huh? Let me get a clip so I connect it to ground permanently. So let's see. Let's get the voltage into here. Let's see if my grounding works. Grounding works. So let's see. 5-volt dual should always be present right here. Right there. Yeah. 5 volts. Okay. Yeah, this stays consistent pretty much. Let's try that again, because I'm slipping off with my probe. So let's reset the board. Yep. Happens. And there's nothing happening here. And if I press it myself, it goes down. Yep. So that doesn't do anything for us here, sadly. That isn't a problem. Some LCDs have pass-through signal output to capture. Yeah, it's working. The flash controller max chip can be removed if it's bad. Yeah, I've seen that this can be removed for that, but yeah, not our problem in our case. Interesting. What else could it be in here? Like, theoretically, I think this is... Yeah, this has firmware on it. Like, the PWM controller can go bad and, like, have faulty firmware on there or be internally bad or anything, and then can report an issue. But to find that out, you would need to get another chip, reprogram it, and put it onto here. And we do not have the firmware for it. Let's take off the chipset cooler. And let's see if there's anything around there, maybe knocked off or broken, just to be sure. Let's switch to overhead again. Let's see. Where did I put my screwdriver? Right here. So let's see for this chipset. For most chipsets, I really don't care for the cooler, but X570 gets so hot, you always have to run it with the cooler. Like B450, B550, all don't really care if you start the board up without a cooler, but X570 is hot. So, let's see if we can find anything related to here. The standoff is off. Doesn't really matter. Let's get that rearranged a little bit so it's easier to see. Nothing so far. It all looks clean. So it fails with what codes on RAM only or VGA, non GPU CPU. So it goes from a CPU LED to a constant boot and VGA LED, both lit up at the same time. If you don't supply RAM to it, it actually gets stuck on a DRAM LED and has then constant power consumption. Okay, so nothing to be seen here. Let me put this back because I want to show you again the behavior so we are all on the same page. Let me see, where is it? Struggling to put the cooler back on. There it is. Let me get my screwdriver again and put this back onto here. And the other screw. I have not tried it with the GPU in, but we can certainly try that. That's a good call. So I will show you under the microscope for the LED sequence. So everyone is at the same point. So everyone knows what are we talking about and what the actual issue is currently. So let's see the LEDs. Let's get the power supply attached. Of course, my wires are in the way. Like that. And let's see right here. So you can see. Board, please turn on. CPU LED. And then jumps to VGA and boot. And it stays like this constantly. And we have stuck power consumption and not going anywhere. And it just hangs like this. Nothing happening, no more postcodes. And if we take out the RAM, if we now turn this on, this is CPU, DRAM, and then stuck on DRAM. Doesn't go anywhere. Yo, Slovtag, very nice to see you here. So it's not enabling GPU or CPU. It's a good question if it's not enabling that, or if it senses a fault and goes into a fault condition. Because I've had that before as well, that when it sees a fault with CPU, for example, even if the voltage is there for vCore, that it then disables everything and goes to a like locked state. I've had that happen before as well. Let's see with the GPU. Let's do that. Let's go into the overview. The GPU is a good call to try. So let's prop this up so I can actually get a GPU into here. So CPU in here, GPU in here. And let's get the cooler back on so my CPU doesn't fry. So let's see this again. CPU. And same thing, VGA and boot. Obviously, we will have more power consumption now because there's a GPU in here. Let's see, let's run this for a bit, just to be sure that nothing changes while doing this. But it doesn't appear to be. Just to be sure, I want to connect a keyboard onto here. But there shouldn't be, it shouldn't have booted actually. Yeah, nothing. Try a different CPU. We have tried different CPUs, but we can very well go for another CPU as well. Let's see. We have tried a 2200G. This was a 2600. Let's see. What else do we have in store here? What we could be using? I have a 3100, for example, here. $3,100 in. About the same power consumption, CPU LED, and boot and VGA LED. Same behavior. Two different CPUs, so it's mobile chipset issue? Doubt. I wonder if it's chipset issues. It would be a first. Like I have actually not seen an X570 chipset fail before. Like not a single one. In all of the repairs that I've done, not a single X570 chipset was dead so far. Might be the first one, who knows. Oh, so one more thing. 4,300 I can still offer to try it out with. CPU LED and same. Okay, let's switch back to a known to the 3100. What I want to do maybe, I want to see if there's any specific amount of heat in any of the phases of the of the V-core. So let me see if I can get the thermal camera hooked up here. Try using postcard for specific debug codes. I have tried that, but sadly nothing. Press chipset while booting. Chipset while booting is also a good idea. Let's try that. That's also something. Just a little bit of pressure that I can try. It does? Why? Now we have a RAM LED. That's interesting. Let me retry that. Oops. Okay. Let's reseat the RAM in a different slot. Was that just coincidence? Yep, same behavior. Let me try this again. For a second there, I had a different. I just had like a DRAM light, but nothing happened. It was just stuck. So let's try that again. I'm going to press a little bit onto it. No, same behavior. Yeah, doesn't change anything. I might want to do it with like without the normal cooler onto there, but I doubt that we get any change right here. Yeah, nothing. Same behavior. Reflashing device might be worth trying. We might go for a different BIOS, but I don't feel like this is a BIOS issue. Yeah, thermal camera. Let me get my thermal camera. Yeah, sorry. If I put my mic up, it mutes it. And I just went for a drink and I put it up. So I don't really see anything special. Like, the only thing I want to check is this face right here. And if I go for a reset, there's nothing special. Like, it doesn't pulsate, heat up, or anything. Just, it looks different than this face. That is the only thing. That is weird. Like, those two faces look very different. But those look similar. Like, with having a heat spot, looks kind of like this one. And that one looking a little different. We might want to check the MOSFETs, but I don't really think that the board would go that far if any of those MOSFETs have any problem. Hello everyone, how is it going repair? The repair is going not so great, sadly. But hi there, nice to see you here. We have an issue where this board goes into a boot and VGA LED constantly after going from a CPU LED, and then is stuck in power consumption. We have flushed the BIOS and now currently trying to figure out what is going on. I'm suspecting something around the vCore VRM being damaged or not working like it should, but so far we don't have any sign of that. We have swapped the RAM in different slots, same behavior. I want to go for the MOSFETs. I want to try some. Let me see. Microscope scene. This probably leads nowhere, but I just want to do a quick check with my probes, with my multimeter on these. Huh? What is this reading? What? Do the others read exactly the same? This is just CPU, yeah, this is just CPU, right? Yeah, this is just CPU resistance, pretty surely. Yeah, just CPU resistance. Okay, so these MOSFETs test okay. Because one thing that was weird was that this phase here didn't heat up at all. The others heated up normally, but this phase didn't. Definitely none of them shorted. Hmm. Resistor off value on the Nuvoton. It might. It might be that a resistor of the Nuvoton might be damaged. We need to check that. There are like V-in resistors on the Nuvoton that look on different voltages and then can disable something. So we definitely can check that. My 2 RAM slot not working and indicating CPU LED. You will need a data line tester. Disable MOSFET with probe alternating. Oh yeah, that's what they're hot maybe. No, we just checked with a thermal camera. Gate to source. Hey everyone, hi there. Yeah, gate to source. I don't think that gate to source will be shorted, but we can check that just to be sure. Yeah, nothing. Nothing. And nothing. Yeah, I definitely want to go to the EC chip and want to check those resistors. That is actually a very good call, because this can be one of those issues. For that, I will need a board view. It's probably, no, it's not these. It's probably going to be some around here, I would suspect. Maybe down here. Let's go into the board view and see. So what are we talking about? On the EC chip, on our SIO, there are voltages coming into them, which it monitors. Like, for example, it probably starts here, or like there. HMREF, CPU MST in, CPU T in. This, for example, takes VCore as far as I know. Or SIT in. This is connected to a transistor. Or VN5 is probably the 5 volts, or like the 5 volt dual that it checks. Oh, it's it's VDDP. Yeah, it checks for VDDP here, for example. Do I have a diagram of the power sequence? I do have a diagram for power sequencing, but the board goes so far as checking for CPU and RAM, so it shouldn't be an issue with actual power up sequence, but the BIOS seems to see some kind of issue. Just came. Can someone tell me what the issue on this board? This motherboard is having a fault. It turns on, goes to a CPU LED, to a DRAM LED, and then stays constantly on a VGA and boot LED and is brain dead, and then does nothing after that. So, we will have to see for these voltages coming into this. It's just going to be, so from pin 110 up to probably pin 119, we will have to check each pin if they have voltage. What is this? TSID, APUSID? No, this probably isn't connected. Yeah. So let's see. We'll start for, oh yeah, from there. From pin 104, V in 0. History of this board, no idea. I have bought this board like 2 years ago off of like something that is similar to Facebook Marketplace, and I have no idea what was wrong with it. Okay, let's then go from pin 1, 2, 3, 4, 5, 6, 7, 8. Pin 8, so 104, to like, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9 from the end. Yeah, pin 8 from here, 4, 5, 6, 7, 8, 104. Yeah, let's start from here and check for these voltages here. Oh, this is going to be quite tedious. But it is a good call to check these. I've had it before where resistors go bad on there. Let's swap to the microscope again. So let me get a ground clip hooked up to here, so I don't have to hold the ground. Let's get the CPU into here, get the cooler on. So let's see then. We want from the 8th one. So 1, 2, 3, 4, 5, 6, 7, 8 from this one. So from this one that is not connected to further, and then check everything from here. Let's go into voltage DC. Just probe at the resistor. Yeah, well, you would have to see each of individual resistor all the time, which one to probe next. And in this case, you just go pin by pin and can look all the ones. I don't trust myself probing near other pins. I always touch the resistor pad. Well, I think I have a steady enough hand to do this. We will first try it like this. So, oh, I don't have the power in. So this into here, this into there. Let's see. Passive power consumption, as always, 130 milliamps, turning it on. And let's start to probe then. So, this pin first. 0.9 volts. Okay, there's something here. This pin next. 0.9 volts also. Okay. Next pin. 1 volt. Then this pin. 0.6. This is kind of low. It goes to this capacitor here. 0.6. Okay, we might want to have 0.6 in mind. 3.3 volts. 1 volt. 2 volts. 0.75 volts. 0.75. Nothing. Okay, this is also interesting. This is, I think, was it this one or is it that capacitor? Yeah, this one has no voltage on it, which is connected to this capacitor right here. So no voltage for that. For one, we had like 0.3 or 6 or something, that was what it was. And this one doesn't have any voltage. And this one next to it was fine, right? No, this one also doesn't have voltage. So these two might be interesting, what they are supposed to be. Let's see a little bit further then. 0.68 also. 1.5. Also nothing, but I don't know if we might be too far already. But this one also has nothing. So from that capacitor to further, let's see, this one has 1.8. Then this one is from this capacitor right here, 1.8, and the next one is from that pad over there, also has 1.8. Okay, so these two resistors are weird. This one doesn't have voltage, and that one doesn't have voltage. Does it have voltage there? Also nothing. So on both sides of this resistor is also nothing. Interesting. And it does go to the board somewhere there. So definitely have to check these two. And one of these had like 0.6 or something. Yeah, 0.6 I think might be fine though. So yeah, let's check on the board view what these two are for. I had a case where I bridged caused a bridge on a SIO, I had to retouch. Yeah, that can happen. I have done something similar as well. A multimeter won't help here. You need an oscilloscope. I'm actually not sure because if the voltage would go away, then yes, I definitely agree with you. But most of these are just power lines. So they are either there or not there. Like they're very it could be that you're right, that it turns off, but I don't think it's the case here. Let's go to the board view. So this resistor this has 0 on it, but why? This is VN5 and this is CPU VDDP. How is that 0? Because I'm pretty sure we seen something here. And the CPU wouldn't really turn on without that. We need to check if this is 0 while we start this up or not. And what was the other one? VN7. Where does this come from? From here, ATX5 VSB. Okay, we will have to probe these two while it isn't in its fault condition yet. Let's see. So this is just 0.9 volts VDDP and 5 volts VSB. I cannot imagine those to be signals. So those should be just two voltages that are present here. And currently I cannot see them. So let's try this again. So we see passive power mode. Let's see for the 5 VSB. In passive mode, the 5 VSB should be here. Right there. Okay, I cannot see it there. 1.5 volts. Am I at the wrong point? Didn't it say this? Okay, now this has voltage. And this doesn't have voltage. Why did I see 5 VSB? Let me see once more. Where did I see 5 VSB? Why is that 1.5 volts? Like, if I could see any 5 VSB here. Maybe here? Yeah, there's the 5 VSB that I saw. Okay. So, the 1.5 volts is definitely here. But the VDDP voltage is not here. Let's see if that appears and then this appears right here. No, it's never there. Okay, this is never there. But the VDDP is still on, right? I think our VDDP is actually going away. 12 volts for the VDDP is there. Very interesting. Let's go to the VDDP here. Have a look right here. So we have the big input inductor right here. From there, 12 volts. But we do not have anything on its output. Let's turn this off. I think their pull-up resistors, their values are quite high. Hi everyone, hi there. And hi Dark Shadow. Let's see. So probing displays, 0. Do we not have, yeah. We just don't appear to have the VDDP. Really? Oh, this might be a CPU. Oh, yeah, I've been fooled by this before. This might be related to the CPU that this VDDP isn't there. Yeah. I have been fooled by this already. Let me plug in a different CPU, and then the VDDP might be just there. I have been fooled by this before. Thanks for uploading that much content on YouTube. Thank you very much for watching. I try to have one video up every Saturday. So let's see. With the different CPU, still nothing on VDDP. Okay. Let's cycle through a few CPUs and see how it behaves if the VDDP is never present, because with some CPUs it definitely should be present. Yeah, with this CPU it is present. This is now the 2200G. Yeah, that was exactly what I was expecting. That this is only an issue with like a different CPU that this is not present. And if we have a look right here, we should now be seeing those voltages. Yeah, 0.9. And this was 1.5 volts before. Yeah, now it is 1.5 volts. No idea what was the issue before, why I couldn't see voltage on here. But yeah. So it appears to be that we have voltage everywhere on all of these. Like all of these pins lead up somewhere, and you can probe these resistors. See, just like he said in chat. You can probe all of these. One signal I want to check is a signal called ATX power OK. It should be close to here as well, somewhere. Oh, this resistor has nothing on it, but it might also not need. Let's see what this resistor is for, but I've gone too far anyways off. But I want to see for the ATX power OK, and I want to see what that resistor is for. Let's go to the board view. Any other volt pin changed new CPU? No, not really. The voltages seem to be all the same. So let's check what does the... Oh, this is just test mode. Okay. Let's check a signal that is called ATX power OK or something like that. Because I had that problem here. ATX power OK. It is right there, and that is connected directly to there. Okay. Yeah, one thing I might need to do. Yeah, VRM is working. We have 1 volt there. I might want to plug a normal power supply into here and not use the 24-pin adapter that I always use. Is there another one that is also like called an OK signal? If there's like an all power good signal or something like that. No, I can only see this ATX power OK. Okay, let's go over and plug in a normal 24-pin adapter into here instead of using the adapter that I always use, so I can see the current. So let's see right here. I have to dig this out. Under my table is the actual power supply. Right there. Not sure if it's even plugged in at the moment. Let's see. CPU power. And 24-pin adapter. Let's see. Does it react to the power button? No. Oh, yeah, I don't have it plugged in. Oh. Let me plug it in. Oh, what happened to the picture? Let's restart my camera. There we are. Now everything plugged in. Let's see. Turning on, CPU LED, and the same behavior. Okay, that has nothing to do with it. Sad. That was one more thing that I wanted to try. But yeah, exactly same behavior. I want to see for one thing, where's the speaker? Right here. So let's unplug this again. This was a no-go. So away with those cables again and back with our setup where we can actually see the power consumption. Does this thing beep when we have no RAM in here? I would expect it to beep. Yeah. If there's no RAM in here, it actually complains. So it definitely enters the BIOS. It definitely goes through the routine. But no beep codes in this mode. I'm just trying different RAM sockets just to be sure. Nothing on that. Let's try, what is it? B1. I haven't put it in yet. Yep. In every slot, same behavior. Any HDMI signal on board can cause. I've seen it that there was a regulator, like a 5-volt regulator for the HDMI that was shorted to another line, but then the board instantly turned off instead of going into a state like this. I usually take the power sequence diagram and look at it with an oscilloscope. Try other RAM. Yeah, I can try other RAM, but yeah. This RAM is known good. It should be working, but I can surely try other RAM in here. Yep, nothing changing. 3 amps. Let's put this RAM into a different slot as well, just to be sure. Yep, same behavior. Let's go for one more slot. Let's go for the very first one right here. And no change. Yeah, according to boot sequence, rear voltage is final voltage. Let me show you. (1.1 volts. V-core. No beep codes, nothing. This one got me stumped. It's so difficult to think about this because, like, the original issue that I've seen was the damage on the backside. I want to revisit that and probably put on another chip there. Because what most of you didn't see that came in later, the only thing that I've ever found on this board that seemed wrong was on the backside of this board, behind the VRM, that there were actually damaged components there. Let me show you again. So on a MOSFET driver, right here, we had a knocked off capacitor. That cap there was knocked off, and I also had to replace the chip that was on here. And I might want to just replace that chip again, just to be sure. And one more thing that we saw is that, interestingly enough, most phases use 2.2 ohm resistors, and this one happens to have 3.3 ohm resistors on here. But I'm pretty sure all I've done is only replace that capacitor and put it into place. But I might want to see if I can get one more of these chips. 3598, it is the same, right? 3598, yep. Yeah, and just go with that, maybe. Yeah, I've tested all of those resistors, ohm test. They are fine. Is there any missing voltage? No, we've seen all of the voltages. It feels unlucky to have physical damage and then an unrelated fault. Yeah, it seems weird. Like, most of the time, boards have a single fault. Like, a single thing that knocked them out. It's very rare that you have multiple things that are wrong with it. But we do not know if after this incident where this got knocked off, the board already stopped working, or if it just happened to work even without that. Thermal checked rear. No, we didn't really check the thermally the rear. We can do that. Let me see if I can make that happen with my setup. Thermal camera, and let's go to the overhead then. And let's zoom down a little bit so we can actually see this right here. So let's turn this on. Let's get the macro lens off of here. Let's turn this right here. And power button. Where's my power button? Did my power button fly off of here? No, there it is. Okay, so let's see here. Actually, that one heats up way less than the others. That is very interesting. Like, it does heat up, but the others heat up way more. Interesting. Like, you can clearly see that. Like, all of the others behave similar to each other, and that one just behaves differently. And that is the one where the physical damage occurred, and also, I replaced the chip before. Because it does heat up, but definitely not just like the others. It is weird that everyone is in line except that one. I will definitely have to replace that chip, or like maybe components around there, just to be sure, because that is weird. Let me see. I need to find out what chip that is. That is an IOR3598, I think. I need to check if I have those on some of my donor boards. Let's go to the board view just to be sure. I can go closer just in a second. I want to see what components these are. So this is an IR3598. Okay. There's a 0 ohm resistor here. This is not fitted. A capacitor, 0.150 volts. Then 2.2 ohm. These quote to be 2.2 ohms and not 3.3 ohm resistors like the others. That, like, I don't know if that would make a difference, but that is definitely not right then. And another 0 ohm. So 0 ohm, 0 ohm, 2.2 ohm, 2.2 ohm. Let's put 2.2 ohm in here. Okay, yeah, let's do first, before we change anything, go again onto there with the thermal camera, just to have a good image of that. Oh, and then replace some components around there once more. Oh, let me get this set up. So back to the overhead view. Let me put in the power. Get my phone into here. Let's zoom down. Get the macro lens. Let's see. Power on. Get my arm out of the way. Let's have a good look right here. Okay, I don't see anything on any resistor, but the chip definitely behaves differently. So yeah, no residual heat from anything else, but too little heat from that one. Okay, then yeah, I definitely want to replace whatever this chip is here and the 2.2 ohm resistors just to be sure, because that is like there's definitely something wrong there because it's not behaving like the other phases. It might be a fault with the PWM controller, could also be, but I first want to see if I have these chips somewhere. Let me see. Do I have these in stock maybe? Let me see. 3598. I actually seem to have these in stock. But I would rather take them from a donor board, to be perfectly honest. I will keep this on my bench as well. Let's see. I actually have these here. But let's go into board views for my donor boards and let's see if I can get any from there. Just check the voltage drop shunt. This will help. With Paul Daniels flexible view, paid version can just sell all P. Oh, interesting. That would make life a lot easier, obviously. Let's see. I most of the time take stuff off of this board. Does this use? No, this uses other ones. Okay. Let's see for my other donor boards. Schematics, donor boards. Let's see here. This one. Alternate is search mod everything. No, this uses UPs. On both sides, probably, right? Yeah, UP 1962. So not what we need. What else? What other boards do I have that might have this? This one. This is probably directly driven by the controller. Yeah, this probably goes directly to the controller. Yeah, this goes directly to the ISL, so this doesn't have any MOSFET drivers. Are you on any Discord servers yet? Actually, yes, I am on a single like I'm actually on all of the bigger repair ones. Like the Learn Electronics, Northwest Repair, and all of that. I'm actually all over there. And yeah. Let's see. Lower gate. What is this connected to? Also an RT96. I'm running out of boards where to look for parts. Okay, let me go into my stash quickly and see if I can find any of these. Oh, so many boards and I cannot find this part. How can that be? This one, what is this? This probably is the UP board, right? This has the marking 7B98. Do I have that open? No, I do not. 7B, no, this is a Z390. Z390, this is 7B98. Do you have anything for us here? Also UPs, man. This one does use MOSFET, DR MOSes, so this one probably doesn't have it. This one I've looked. This one also has DR MOSes. This one I had a look already. This one uses DR MOSes. This might have them. Let's see. MS7C56. This is B550. B550 MA Pro with 7C56. Does this one have the unit that I need? I might be wrong, thought I did. did text inside PDF. IR3598. This one actually has some. Great. So I can actually take some off of a known good source. That will be great. So let's desolder one of these and put them on. So let's go under the microscope. Oh, finally, the last board that I could check actually has the parts that we need. Whew. Interestingly enough, this one uses them on the front side of the board. Let's see if we can also take resistors off of here. If we actually can find also 2.2 ohms here. No, I'm not under my YouTube name on Discord servers. I started to go onto those servers under my like Discord name or like my usual name that I use online, and I've just kept going with that. There are two 2.2 ohm resistors, and there's the actual MOSFET driver that we need. That is very great. So let's start to take these off of here. So flux onto the resistors and the actual part. And on the resistors, we can apply the leaded solder then. Oh, wrong view. Microscope. There we are. Now you can see what I see. So applying leaded solder. Let's take the hot air. We need good tweezers. Let's take them off of here. Resistors are off. Let's see so that we can actually take off the driver. And there's the driver off. Hairy chip. Yeah, you know, all of these boards live in storage. And I do have a fluffy cat going around everywhere, and his hair gets everywhere, no matter what you do. Let's go to the patient again. Oh, let's see. So let's prepare the place. I've actually never used ceramic tweezers before. All I've used are just metal tweezers. And like I didn't really see the necessity to change anything of what I'm doing currently with the tweezers that I use, so yeah. I guess they absorb less of the heat that you want to put into the components. We might want to replace capacitors too here. If we already have a donor board that has the exact same topology, we might as well just replace everything. But let's first start with the chip and the resistors. Okay, that is all off of here. Let's place our new components. You and you. Let's get these two first tagged onto here. So you go there and there. You go here and there. Let's now get the chip onto here with the top with the marking to the top right. Let's try this now. Oh, flip the chip. No. Crap. Different pair of tweezers. Like that. Oh yeah, using tweezers with my left hand. Great. Stand-up comedian, die resistor. Don't like it too much how the chip is sitting. Like that should be fine. Man, what a botch job. I need to clean this up a little bit and then see for the connections. So let's clean everything while it's still hot. Man, that resistor doesn't want to work well for me. But I think it's connected. Even though it looks awful. That should be clean enough. So, let's see right here. The resistor is barely touching, as you can see, but it is connected. Chip looks fine on this side. Let's swap it over. Let's see from here. Just to focus. Little bit of a solder blob of the very left chip pin there, but it should be connected. Let's see, can I get... No, I cannot. I need to get the microscope further to here. Also fine connection right there. And looking fine right there. Okay. Yeah, I might touch that up with a soldering pen. Let's see. Get a little bit of flux into there. Get the soldering iron clean. Yep, much better. The blob disappeared. And it's just a connection now. Okay. Let's clean this off once more, and then let's try it. I'm very interested if the heat signature changed now. We might also want to see for those capacitors, because these capacitors can make a huge role in how these work. And I'm not too sure what value this capacitor is that I put onto there. And for the others as well. We might just want to replace all the whole phase, like whatever is there, just get rid of it. Be sure that it's off of a known good board. And yeah. Because like I said, it's been so long and I don't really know what kind of parts are onto there. And even those 3.3 ohm resistors that looked pretty stock seem to have been not the right part onto there. So let's go over to the overhead again. I would lay it down so it don't come off again. Yeah, you're right. Putting the resistor properly onto there would be better, but for now, this will be enough. You know, it's certified good enough for now. I'm really interested in how this will behave now. Like, I don't even know what to expect here. Like, if this could have had any change to it or not. It would be great if it would, because this board annoys me. Okay. Passive power consumption. Normal like we had before. Big moment of truth. CPU LED. And the same behavior. Fuck! Oh, man. One different try with the different CPU, and then we go back to looking at the heat. If there's any problem with that. We do have an alternative BIOS chip. You're not wrong. We do have an MXIC while the board is calling for an Windbond chip. Different CPU, same behavior. Let's see with the thermal camera once more if the face is heating up differently than the others. So let's do this again. Get zoomed down onto the thermal camera. Power button. Let's see now if the chips still look different than the one that we replaced. And yeah, they still do. So might be something with those capacitors, because that one chip still heats up less than the others. So we might want to replace the capacitors as well. But going for a Windbond chip is actually also a very good call. Try the PWMs. On the power supply, you mean checking each phase? Or do you mean the signal for the PWM controller to the MOSFET driver, or checking the actual CPU voltage with an oscilloscope? But I first want to try to actually take another BIOS chip onto here, because the thing is, very often boards work with not all phases installed. Like, if you have like missing phases, it still can be working. Like, I've shown it in multiple of my videos that if you're missing phases, like I've had like 3 phases missing on an AM4 board and AM5 boards, and they were still posting without a problem. But getting the right BIOS chip into here is actually a very good call. Let's see now. Let's go here to this MXIC. So let's protect the area again. Let's see. The chips that I have are these Windbond chips. 25Q, 256JW. This should be the ones. Microscope scene. Face is a bit out of balance. I wouldn't worry about it. Yeah. It might be that the phases are out of balance. Yeah. Let's see. JW was the right one, right? Yeah. Okay. So, let's then replace these chips and flash it once more, and then go from there. So there's my tweezer. Chip is off. Let's get the new ones in here. So I'll probably have the same issue as I often do. Yeah, this is the smaller footprint. Yeah, I won't be able to probably get this onto here, huh? Yeah, no, there's no way. Crap. Okay, I think that board where we've taken off that MOSFET driver also has that kind of BIOS chip. It does. Yeah, that's a win point, I see. Let's take off that one then. I will need to get the right size BIOS ICs as well. I'm quickly just taking off of the donor board. I know you cannot see. Let me just quickly take it off of here, put it onto our patient board, and then go ahead and flash the BIOS once more. Man, this B550 board that I'm taking it off has a lot of thermal mass. Took a long time to take this off of here. So let's see. Here's our Windbond chip. Freshly taken off of a different board. This time the right package size. And now it's on there. Let's get this into focus. Looking just fine. Let's get this protection thing off of here and clean up the area. I could be using wires to just attach it. But I did have this one. That is the proper size. So, yeah. Going for this one makes it easier. I will definitely have to order the right sized ones. Don't know how I managed to get like a size smaller when I was ordering these. So, chip is properly on there. Let's go over to the computer and actually flash the BIOS firmware onto here. So, here we are. Let's see if it recognizes our chip. And it does not want to... Oh, there it is. Now it read it. Okay, so let's get the right firmware into here and let's program it. Yeah, this one this time does have a progress bar. Okay. Different JTAG ID. Yeah, I've heard about that before, that might be an issue, but I have successfully replaced MX ICs with Winpoint ICs. They can have support for both. You know about force starting in an ITX. It's it this isn't a problem with force starting. It reacts to the power button. We do go into a BIOS cycle, so that is not the problem here. I did it once. I'd rather get proper so the BIOS can be reflashed later by end user. Yeah, exactly. On Intel, you headset turned off there. On Intel, you can see them in the Scepter region of Intel bin files. Very interesting. Cool that you can actually look for them there. WUAV tool. Most definitely. Oh, this board is annoying. Oh, we've been on this for how long have we been on this already? Let me see. Uh Analytics. 2 years you've been on it. Yeah. Actually right. You're actually right. Hello there, Invest. Oh, I hope that this can fix the issue. I'm kinda done with this board. Oh, there it is. 2 hours, 45 minutes. Man, time flies. Almost 3 hours on this board again? Oh my. And this is not the first time that I've been on this board. Like, I've tried to repair this like twice before at least. I think I remember this one a while back. It's good to revisit. I think I have another one that has a similar issue. That is also an MSI, but that has a black PCB that had a similar issue, I think. That might have been my very first live stream. Okay, this worked. Let's go to the overhead cam once more. Like, this is definitely not the first time I've seen this issue, but I don't think that I've been able to fix it the last time that I had it as well. So let's see. Let's get the 2200G in here. Oh. I see you have fun with the spot. Yeah, a lot of fun. I'm having a blast. So let's see. Pressing the power button. CPU LED, 3 amps. And the same. No change. Wow. This board. Next is replace Nuvoton. Oh. I'm still curious about that CPU phase, to be perfectly honest. I want to replace those capacitors that are on there. Just to be very sure that they are also fine. Because I've replaced that one, but I don't know which value I took. And like I said, like if you have an issue in one area, it is very likely that it's only that area and nothing else. Because having 2 issues on an ATX motherboard is very rare. Like if you have like 12 volts going into 5 volts, sure, there's multiple things shorted. But if you have physical damage on one spot, it's very unlikely there to be more electrical issues. So I want to be taking the capacitors off of the donor board as well and be putting them onto here just to be very sure. So let's go under the microscope. I think it's a 3-leg component that crystal ball is foggy. Crystal ball is foggy. Yeah. Now I got it. Took good time. Could be a small transistor 3-leg one somewhere, yes. So I want to replace all of these capacitors here. I've checked these resistors before, but these capacitors I want to replace and make sure that there are the right ones that are on here. So let's remove these first. Kinda interested how this bot would behave if you have no capacitors there at all. Kinda want to see that. Just quickly. If this makes any difference for it. Here are the LEDs. Doesn't seem to make too much of a difference. But currently we're only on a DRAM LED. Which is weird that it's different than before. Let's see here. Let's put the RAM into a different slot. Yeah, no. Behaves the same. Behaves the same with and without capacitors there. Interesting. Yeah, let me put capacitors on here from the donor board. Where I definitely know that they are good. Because what I expect that could also have happened is that when there was damage done to there, that the capacitors also got a hit. And I just want to be sure that those are good. because we are dealing with with like high frequency signals here because of the PWM signal, and capacitors do make a big difference there. So let me see which of these is what. I need to get into the board view of that board. The board is short, break it in half. Funny enough, you say that. My wife always tells me if I have a board that I cannot fix and just get frustrated about it, she always tells me to throw it out the window. Just open up the window and throw it out and be done with it. So let's see. Let's go to the board view together. So which one is the board that we are actually working on? We are working on 7C, this one. This is the one that we're working on. So we removed this capacitor, 0.1 microfarads at 50 volts. Then this one is the same one, so these two are interchangeable, and 1 microfarad, 16 volts. Okay, let's have a look. There's a 0.1 microfarad, and the other one is also 0.1 microfarad. So the two big ones just go where the two big ones are. And this is a 0.1 microfarad. And is this? No, this is a 1000 pico. What is this? Then this is a 1 microfarad, 16 volts. So we take these two big capacitors and put them wherever because they have the same value. And we take this small one and put it there. So let's do that and then try again. The fact they can't put the legend of the LED directly in front of the LED is impressive. We can rebuild it, the 6 million minute board. Okay, microscope scene. Let's take off these resistors. Capacitors. So put leaded solder onto them. This one. We need this small one right here. And we need this big one. So I need something where I can put them so I won't lose them. I'm probably going to take... let's put the patient board somewhere close so I can take them off and instantly put them where they need to go. So let's heat up our area. Big capacitors off. Small capacitors off. And one more big capacitor. Okay. Let's get the donor out of the way. Get our patient carefully into the shot. Right here. So let's see. So this is one of the big ones. This one belongs onto there. Let's get the tag down. So you will go there. Then we need the small one in between, and this one, you will be sitting there. Let's get the small one. Small one will sit here. Something like that. And let's see to get that one out of here. If I can get this off with my soldering iron. Just like that. Get this one out of here. Let's try to put that resistor into place properly. Kind of like that. We will reflow it. And now for the big capacitor. See, you go here. And also there. So everything is in place. And now just reflow everything. Yeah, the capacitor has ripped pads on it. I know that. That's just why. Oh, you mean this one? No, the 0402 doesn't have ripped pads, pretty surely. The only ripped pad is that one of the 0602. Pretty sure this one sits properly. Ah, that one also. So, connections are made. Don't really think this makes a difference, but I want to say that I have tried that as well. Made sure that the whole thing is changed over. Everything has been reflowed. Everything has been changed to known good components. Not the greatest soldering. Let me see that the connection from that right capacitor is actually like it should be. Because it kind of looks like it just sits on the pad. From there to there. You know, it is soldered. Okay. Was clarifying my previous match. Sorry for the confusion. All good, all good. Good morning, Daniel. Nice to see you streaming. Hello there, David Strider. Good to see you here. So, don't really think this made a difference, but we kind of running out of things to try. So, our overhead view. Once more, power consumption. Turning it on, CPU LED, and the same. It was worth a shot to try that as well. Oh, yeah, one thing I suspect that it might be the PWM controller here, actually. That might have taken damage, but I wouldn't really see a reason why. Even if one of the phases isn't working, like, why would the board care? If you ever want to do SKSP3 MD Epic Super Micro Shenanigans, let me know. I will prep and pack my... I gave up. Don't know how to use them. It's probably incompatible. Oh, man. Like, I've had a few Epic boards, and yeah, they are a pain to repair. There's no schematics, nothing often for them. Replace it. Why ponder if you have it? Yeah, exactly. That's why we replaced all of the capacitors. But just to be sure, I had them. Oh, you mean the controller? Well, I don't have it, and I don't have the firmware to replace it with. I'm thinking what else this issue could be. Oh, what else could we try? What could we think about? What could be missing on this board for it to behave like that? Because the voltages seem to be there and they don't seem to be disappearing. I want to see for resistors and transistors around the BIOS chip. Let's go under there. I want to check each of these resistors for their resistance value. I've had it before where resistors near of the BIOS go bad. Well, it's stuck on RAM, so the data from the CPU will go to the RAM. No, it's actually stuck on a boot and a VGA LED. So let's check. Most of these are supposed to be like 10K. Okay, this is a 0 ohm. We'll have to look into the board view. Let's check from there to there. 10K, okay. From here to here. This is like 100K and it's out of my range. Yeah, 47K. So 0 ohm, 10K, 47K. Let's see right here. Also 0. And just 2 more here. Just had a reading for a second. Where is it? There, 10K. And 0. Okay. Well then, let's go into board view and check out these values. If they are correct. How are your classes course learning going, Daniel? I am just fine on courses in university. Currently, there's one more exam that I need to write in basically exactly a month from now. And yeah, I've already had 2 exams this period, and yeah. So let's see. This is not fitted. This is not fitted, and this is a 0 ohm, just like it should be. Where does it lead to? I'm wondering. Just to the SPI header and then there. Okay. Then we had a 10K ohm. This is also correct. This is for the 1.8 volts on chip select. And then there's a 47K. That is also correct. Okay, this is for switching the power. Let's see from here then. This is a capacitor, another capacitor. Not fitted, not fitted. 0 ohm resistor. Is that 0 ohm resistor there? I just checked that, right? That is there, right? And then we had 2 more a little bit further. Let me see. We had like, what was it, 10K and 47K, or no, 0 ohm and, oh yeah, 10K and basically 0 ohms, 10 ohms, okay. This is just another capacitor. This is also not fitted, and this is not fitted. And components around the BIOS IC seem to be fine as well. Whew, tough patient, tough patient. Congrats on further building your knowledge. That's great. Yeah, thank you very much. Well, uh, like the things that you learn in university, very rarely have anything to do for like, for example, repairing something. Like we'd learn completely different things. Like none of the things that I learned in university would help you in any way to fix ATX motherboards, for example, or any electronics in general. Ah, this board, man. I really still feel like this has something to do with the BIOS. But all of the components check out. I've replaced the BIOS chip twice. All of the all of the lines look fine. Let's check with the data line tester if the connection between the RAM and the CPU is fine. Because I am getting desperate here to find anything that could be bad with this board. What is the course learning geared towards? I'm studying electrical engineering actually. And like the last courses that I did was one of the last ones was actually pretty interesting. It was about buck converters, boost converters, H bridges, about converting single phase to three phase, and converting AC to DC and DC to AC. So that was actually quite interesting. And another one is a robotics course that I took, where we learned to actually program a robotics arm in a programming language called Rapid. It was an ABB roboter arm, if you know that. And the other one is called System Theory. That is everything about like signals and stuff. And Z transformation, if that tells you anything. So let's see right here. There's one LED flickering a little bit down there, but the contact can be there. So that is not the issue, just dirty contact. But all of the other LEDs are on, that should be on here. Let's check another slot just to be sure. Let's check B2 also. Yeah, and B2 looks the same. So definitely not an issue with that. Have you tried to crush the board? Should fix it. Boah, I would love to crush it right now, to be perfectly honest, and just be done with it and throw it out the window. Okay, What else to check? What else to check? What else to see on this board? I wanted to go for visual inspection once more. I know I've done it at the beginning of the stream, but I want to go around this once more. Just to see if I have missed anything. Get a thorough view of everything. Any broken trace or any ripped off components anywhere. Oh man. If you fix the spot, you can celebrate with some salted caramel chocolate. Yeah. Fan will get power spin, power on. If it spins, it's probably BIOS or something related. Yeah, the bot turns on and fan spins, and yeah, BIOS flash 2 times. Both times we replace the BIOS chip itself. And yeah, check the components around the BIOS now. And yeah, nothing so far. Oh, everything looking fine. Please just throw a broken component at me somewhere so I can be done with this board. But it's all looking too fine. We might want to check for something that is called all power good. Power good signals is one of the few things that I haven't checked yet on this board. Most of the time it comes around here. So we probably will revisit this right here. Reflow the crystal. Yeah, if the crystal doesn't work, you mostly get no boot out of the, you don't even get a reaction to the power button. I've had that before in a video. Nothing so far here. Let's have a look at the backside next then. Too many countries in the EU. I'm very bad at geography. The Balkans are most of the time like, what is it? Lithuania, Estonia, and I'm missing one that I don't know how it's called in English. In German, it's Lettland. No shot anywhere, just stuck on boot up. Yeah, it actually tries to boot up, goes to the CPU LED, then to RAM, and then gets stuck on VGA and boot at the same time, and then brain dead. Did you reflow that square chip? Needed capacitors, resistors you replaced. Chip is not soldered. I replaced that chip twice and still nothing. Yeah, I was going to say BIOS too, but don't know the full symptoms. I was late for the stream. Yeah, replaced two BIOS chips. I flashed the BIOS twice already. Serbia here. Hello there from Serbia. Lithuania, Latvia. Ah, yeah, right. Yeah. So this chip we've replaced twice. A little bit of damage here. Interesting. But pretty sure that is all a ground plane once around. So even if that is damage there, it should be continuous between like another point. But I'm just curious. Give me some copper. Oh, oh no. There isn't even a trace here. Yeah, no. This is just fiberglass damage. This isn't even a trace. The first copper starts here. Yeah, this doesn't matter. What make and model? This is an X570 MPG Gaming Plus from MSI. Is this the same main bro? Yeah, this is the board that we've been fixing the whole time. Yeah. Good luck with the repairs. Thank you very much. Check the current of shunt resistors. Which shunt resistors do you mean? Like, are these being used as shunt resistors? No, right? Like the ones of the how is it called? Of the MOSFET drivers are not being used as shunt resistors, are they? Hmm, 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 hmm. What is this board missing? Why does it complain so much? A little scratch here. A little bit of dirt. Nothing actually damaged. Just looking around if there's maybe any scratch or something similar, especially around like mounting holes. Any trace got damaged somewhere where I didn't catch it yet. I mean, voltage drop of less working IC. Yeah, I could do that. I'm sure you had fixable bot on stream previously. Yeah, the last bot that I fixed, the last stream that we had, I actually fixed a B550 ASRock board with a broken crystal. Discard capacitors out of big bank of capacitors. Maybe data line is broken. Well, they're all different colors. Like, I don't really think that behind the CPU here is any problem. Interesting that these signals are mushed like that. Like, can you see all of these probe points? They all look like they got mushed at some point. Interesting. I've not noticed that before. Like, what has happened to this to the backside of this board? Looking around these screw holes, anything had been damaged. Seem to be most prevalent here in this area. But nothing actually shorting or damaged or cracked. All looking fine. Maybe data line is broken. I've checked the data lines for the CPU to the RAM. Let's start from the beginning. Do we have 12 volts, 5 volts, 3.3, 1.8? Yeah, we do have all of the voltages. We have checked the voltages for the RAM and the voltages for the CPU. Backside looks like oxidized, maybe liquid or high humidity. Yeah, might be, but yeah, the problem is, what would you pinpoint off of that? Like, what would be broken then? So many components on this backside. But still, nothing giving me a hint of what it could be. What a board. What a board. No scratches, nothing to be seen. Don't really think that there's anything here with this trace, but might as well. Oh, trace is totally fine. Tested with different CPUs. Yes, he just checked the USB data plus minus for short. Is anyone from India? Nope. It won't be a chipset communication problem. Probably not. I don't say my country because I am as a woman. You're never prudent enough. Yep. Thermal camera show anything get hot or just normal boot phase temps? So, we've checked with the thermal camera just normal temps. Just check the PCH reset line. I think this thing is stuck in reset. We can check that with the PCIe tester. Let's see. Let's go to the overhead camera. Where's my... let's switch the scene. Let's see right here. If you have look at that, 3 VSPs present, then reset is there. Okay, reset is permanently present. And why are you not using a debug card? Well, there's your debug card. And it didn't really tell you anything more. And if you plug it into the TPM header, it also won't tell us pretty much anything new. Yep, indefinite cycles. We have tried to put pressure onto the PCH without any luck. And yeah, this is looping. This gets into some kind of loop where it doesn't get out from. And I've never seen those codes that we have on there. Interesting that the one postcard that I have gives me codes and the other one doesn't. Why am I not getting codes with this one? Let me try this one again. Yeah, interesting that the one gives me postcodes and this one does not want to. But well, you could see that it was looping. On laptops, indefinitely cycles is usually the EC's own insane firmware. Those are laptops, not sure it applies. The EC doesn't have its own firmware. The EC takes the firmware from the BIOS chip, so it doesn't apply to here. And these don't get programmed manually. Yeah, I wanted to go for power good signals. Let's go to the board view and see for the power good signals. I want to see if any of those are disappearing. The power good signals are right here. There's an all power good and all power max. I want to be looking at these and also onto the diodes. So let's just check for voltages here. So right here, let's get a ground strap hooked up again. So got the ground hooked. Let's see for voltages. Turn this board on. I will need a cooler at some point onto the CPU because it's getting frying hot. So let's see. So this has voltage. Then this has voltage. This has voltage. See right here. This is voltage. This is voltage. These are all connected, okay. Then let's see on the gate itself. 3.3. 3.3. That one has 0. We'll have to see what that is. This has 3.3. Yeah, that might be just ground then, because all of them have voltage except this one. Yeah. And all of these have voltage on them. Okay. Do I have schematics for this board? Like not only a board view, but actual schematics. MS7C37. I think I do have schematics for this. Schematics available on Badcops forum. Yeah, I think I even have them. How much you charge for this kind of repair? I have never charged anyone any money for a repair so far. Let me see. I have MS7C37. Let me see. MSI 7C37. And this is a revision 2.1. X570, right, this one we need. So where is it? X570 here, MS7C3721. Yeah, let's open this in a new tab. 10 hours labor, few parts, text, screen text, carbon text will be more than a new board, yeah. So, What can we see from this? Interesting. This quotes a different BIOS chip on here. MS7C37. Why does this quote a 128 BIOS chip on here? Because the board view pretty surely says 256. Yeah, it does. Interesting. That is weird. That it's quoting a different chip here. This is a version 2.1, pretty surely. Yeah, revision at the bottom right. 2.1. Like my board is. Let's go to the SPI. It might quote it differently here. Yeah. Just the top says that, but the actual SPI ROM here says the normal 256 version. Let's go from further from the beginning again then. This is memory channels. This is also the CPU. No, this is the CPU. Yeah, this is CPU. All three. This is also CPU. This is more CPU connectivity. White background just hurts us if we can propose exchange PDF runner with dark mode. The problem is the actual pages are white. You can see I'm already in dark mode, but the pages are white. So I actually cannot change that. I'm very sorry if you're like in a dark room on a phone or something and looking at this. Sadly cannot change that. Because currently I just need to look around and get some ideas of what this still could be. What I could be testing here. Because I definitely know the board is permanently stuck in reset. Congratulations on 10k subs. Has it actually gone that far? That is great to see. I was actually I was checking the last few days for my subscriber count and I actually got to 10k. That is great to see. Thank you very much. Thank you very much everyone for watching and like looking at me getting insane at this board trying to figure out what could be wrong with this. Hmm. Yeah, it wasn't at the beginning of the stream. I checked before as well. I was like, I think 13 subscribers off or something like that. And yeah, actually gone so far, huh? That's actually pretty big milestone. I would have actually never expected people to have that much interest in just ATX repair. If you consider that I do nothing else but ATX mainboards. I might want to try to pull the reset line low by myself. Let's see, where's that reset line applied? Let's go to the board view. Wait until you go retro the channel. Boom. Yeah, I saw that there's a lot of interest in retro, but I actually really like doing like new kind of stuff. Like, I love also repairing AM5 boards, like things people actually can use. Name of software Exchange PDF reader. Oh, interesting. Okay, I might want to look into that. 95% of the boards you repair are gaming motherboards. Very popular demand for those. Yeah, especially like with the DDR5 crisis. So many AM4 and DDR4 boards got really popular. Like they saw a spike in price again. I wanted to check what I wanted to check. Crap. I forgot what I wanted to check. Where was I? The reset line. Yeah, exactly. The reset line. Bum. Reset L. No, this is for the CPU. The reset line. How is it called in here for the PCIe? Yeah, the RAM prices, if they would drop, that would be better for everyone, but it's sadly not that easy. A11, A11, A11. Right there. Let's check on this resistor and everywhere here. I want to see PCIe buffer reset U44. U44. Right there. And there's PCIe reset from here. Which is this PCIe reset. And this comes from, oh yeah, this is that. And this is probably the reset. Yeah, this is the reset for here. It comes directly from the CPU, so that doesn't make sense to try to pull this low by myself. Oh yes, I've never seen the DDR4 after I bought 2 in 2024, just DDR3, 2 and 1. Yep. Like I wanted to get a fourth stick of DDR5 in order to be able to test like to test all 4 DIMMs at once, and then I looked at and when the prices spiked, I just never gotten a fourth one. CPU reset and PM reset. Here are all of the reset lines. Temp sensor, HW monitor. This also does, oh, this is for temperature monitoring. Repair DDR5. I've actually thought about getting broken DDR5 sticks and like replacing RAM modules on it, but I've never come around to it. CPU reset and PM reset. Where are these? U72. Where's U72? U72. Right there. The volt regulator goes bad sometimes. Yeah, sometimes the voltage regulator on them goes bad. And also sometimes they have like SPI EEPROM failures. You can't really repair, just caps central VRM and reflow the chips. That's all you can do. Actually, on RAM, on DDR5, they had a very long issue with the EEPROM failing, or the SPI, SPI? Yeah, the SPI on their failing. Even faulty DDR5 models are very expensive to come out on eBay. I've actually never looked up what the prices are on DDR5, but on faulty DDR5, but I can very well imagine. Right, the KDAC EEPROM, JDC, yeah, SPD, I think it's called. Yeah, exactly. Yeah, that can actually fail. Let's have a look around these here. I want to see for these reset signals around here and around there. Let's see. Right here. This definitely looks fine. No damage here. Let's look at that other one. Where is it? I think is it this one? Yeah, this is also the one. Interesting that this is damaged. But the voltage of this is correct when it's on, right? Let me see for that. There should be 3.3 volts somewhere. Yeah. And this also is stable. I want to see for this reset signal stuff here. This pin is 0.8 volts. Interesting. Okay. This is 4 volts. Interesting kind of voltages we get here. 5 volts. And when we turn this on, this stays 5 volts. What is this? Still 4.1 volts. 0.8 volts. 5 volts. Okay. Daniel, what gauge wire did you utilize to solder your leads for your meter to the mining adapter you have? Your power supply, not meter, lol. No idea what gauge they are. I think they are... Wait, is it actually written on there? Is it 16 gauge? Yeah, 16 gauge. 16 gauge wire. Also nothing here to be seen. Who or what is pulling this board into a reset state? Or not releasing it from a reset state? What could that be? Oh man. I am spinning in circles with this board. Thank you, sir. No problem at all. What else could there be with what was damaged on the backside? Like by now, I've completely rebuilt this. I've completely rebuilt this phase where the damage occurred at first. Like, these are all low voltage, low resistance. Yeah, 0 ohms. 0 ohms. 2.2. And 2.2. These are connected like there should be. Let me check where this is supposed to be connected, but pretty sure that this capacitor just connects to there, just like it does on this phase. Yeah, it just goes to this trace, and then from that trace to there. Yeah, and the trace is definitely continuous from here, right? From there to there, we also have 0 ohms. Yeah. All of that is also there. Let's check these voltages then on here and compare them if they're different to the other phases. Just missing the boot you're just missing the boot sequence. It's not just missing the boot sequence. It actually is in a permanent boot sequence. It actually is booting. It is giving out post codes, but they loop indefinitely. So let's see right here then what kind of voltages we can see. So let's get power into here. Let's turn this on. And let's see right here. We have 5.2 volts. Okay, kind of high. Interesting, interesting. On that 0 ohm resistor, we get 1.4. Okay. What do we have here? Also 1.4. Then the other side 1.4. Then this side of the resistor 5.2. And this side of the resistor 5.2. And that side of the resistor 5.2. Then checking on the cap. 0 there. 5 volts there. What do we have on this cap? 1 volt. I'm checking this capacitor. 5.2 volts and 1 volt. 5.2 is weird. Why is that 5.2? So the other phase. 12 volts. What? 1 volt? What do you mean? Huh? What do you mean one phase has 12 volts and the other one has 5? Maybe heat up the board with hot air to see to get out of loop. Yeah, that orientation is strange for that ceramic cap. Wonder why they did that. Is it looping even without RAM mounted? No, without RAM mounted, it is not looping. It is then stuck on a DRAM LED. CPU mounted. Yeah, it does react to that. Oh wait, that brown on the top left ceramic cap, is that where the trace was pulled off? Yeah, that was where a trace was pulled off. Is this kind of situation I just prefer to just heat the board and PCH chip? Yeah, you could do that, but yeah, I'm really looking around for this area. Why is it behaving so weirdly? I'm still suspicious of this. Where's this voltage come from? This is 5.2 volts. And where's it coming from? It is connected to here. And then the other side of that is just to this capacitor. And this side is, oh, this is connected to this. Oh, yeah, okay. That's why it's so different. Because this one is oh, that's why it's also heating up, heating up differently. Because it's these two. These are these two dual. But who drives this gate? Oh, it's also driven from here. Okay, so this is different because this one is, yeah, let's see for that in a board view. VU3. No, the schematic, I mean VU3. VU3. It's a Hey man, but Medic love your content. I'm still busy with that MSA X370 bot that has overcurrent issue. I put it aside for a second just to refresh my brain. It's driving me crazy. Yeah, I've answered your email of where you need to cut the trace and connect those two together. Um, yeah, it's all around that one component that I've marked you, where it actually senses where the overcurrent situation is detected. It's feeling just hit the rock with bare hands. Yeah. So I was right, not having 12 volts, 502, joking. I fixed the overcurrent protection on in an A320. The overcurrent protection also drove me mad, man. That took so long. CPU SoC driver AC. Yeah, CPU vCore driver AC. Exactly. This is split up like this, and this then just takes the others. Yeah. Because this works a little bit differently. Where's that dual MOSFET thing here? Right here. Yeah, this is VCCP-NB. I will have to check if that is running as well, because I always just looked for vCore, but I have to check if this is also there or not from these dual N-channel MOSFETs. Let's check that. If that VCCP-NB is also running. 75 amps on that max. Interesting. But it must be running because the chip is getting hot. Like, this chip does produce heat, so pretty sure it's running. But just to be sure. Is your part-time job or full-time? This is just so I have a part-time job, 20 hours a week, and I'm studying the other 20 hours a week. And this is just a side hobby I do additionally. I saw, thank you so much for your help. I hope it helps. Hope you can actually figure out that situation. So let's see on the board if both is running or not. Go to the microscope. Oh. So let's see. We have them right here. So we're going to be checking on these. Let's see. This is 1.1 volts. 1.1. 106. 106. 1.1. 1.1. Yeah, they all seem to be there. All of the voltages are there. Yeah, also after those dual MOSFETs, we have voltage, 1.06 volts. So that is also present then. So it probably isn't a problem with this thing, because where is it? Yeah, with this one. Very unlikely that it's still a problem, because it's driving the gates. We have output voltage there. So yeah. Probably nothing to do with that. Whew, I'm hitting a brick wall on this one. The voltages are different with 12 volts and 5 volts then, probably because the gates require different kind of voltages. Because it is being driven. Ho, 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 ho. How long have we been at this? 4 hours. Whew. What city, in case I run into another German that needs repair? I live close to Frankfurt. Yeah, I am from Germany. Hamburg, I guess. The There's post office in Germany. Yes, my Dutch friend drives over border and put post office. Oh. When you spoke to the customer, Daniel, did they rely anything helpful? How the board? I got this board like 2 years ago. I don't remember anything of it. This is not from a customer. This just laid at my place for a very long time by now. Hmm. Hamburger, Frankfurter, American food cities. Get a Geländewagen, a G-Class. I actually am driving a Mercedes-Benz, but I drive a C-Class and not a G-Class. What else to have a look at? Let's switch over to this. I want to look something up. I did have, yeah, I do have an AM4 power sequence theoretically. This one. You live in Hamburg? No, I live close to Frankfurt. PCH reset near Frankfurt. Follow Mercedes man. I have a 200D. I have uh two a CDI 200, I think it's called, from 2006. I guess wrong foot. Any chance you have known good board to compare readings to? Same model? Sadly not. Sadly not this model. So, yeah, this diagram is for AM4 power sequence, and it most of the time ends with like all power good, which we have. Power okay, we've looked at that. PCI reset, and the PCI reset is the actual thing that is weird here. And AP reset. These two lines are not being asserted like they should be. But I'm pretty sure the VRM ready was there. I've checked that. Let's see for power okay, but the power okay pretty surely was just at the top right here. All power good, this is what we have been looking at. And this line is the VR power good, VRM ready, and the chip power good. And all of these were high. You have everything, just check the boot sequence, good to go. Okay, what of this boot sequence am I supposed to check? Tell me. Like, I'm stumped here. If you're telling me to check the boot sequence, what of this boot sequence am I searching for? Imagine he puts GPU and it starts working. We've tried a GPU in there. No change with the GPU. I have love for Subaru's all-wheel drive with less expensive to repair and like Audi. I love Japanese motorcycles, so anything from there I also love. Like I'm driving a Suzuki and I love the Japanese manufacturers. PCIe reset. So let's see then for PCIe reset. We have been looking at PCI reset. It is situated at pin A11. A11 goes to this 100 ohm resistor and to this signal right here on this U gate, U44. Let's go to the schematic once more. U44. U44. It is right here. And let's check for all of the values of the voltages for this then. Let me see in the board view again where to look, just to be sure, so I get the right position. It is next to the PCIe slot right here. This one to check. So let's go under the microscope. This is right here. So let's see. Let's get a ground hook hooked up to here. Let's get my probe. Let's get power into this. And let's see for the voltages. So right there, we have 3.3 volts. When we turn this off, this goes low, and we turn it on, it goes high. And right there, we also have 3.3 volts. We have 3.3 volts. And let's check here. There's a 0 on that. This is still 3.3. And we have 3.3 on that. So the only where we don't have voltage is right there. And all others have 3.3 volts. One thing I want to see, if I manually drive that down to 0, that 3.3 volts, I don't think that anything will change. Let me get a ground clip connected. I just want to see. It shouldn't. I just want to do it very briefly. So do that. And we're going to connect this to ground, spin it up, and same behavior. Nothing changing. Yep. Nothing changing when I pull this to ground. Yep. Okay. So the reset signal for the PCIe is there. There's a high signal there. And pulling it low doesn't seem to change anything. Let's see for that power sequence again. So where we have the S0 state. In S0 state, it is supposed to be high, which it is. So APU reset. Let's see for that. APU reset was somewhere there. Reset L is probably the thing. Because APU, do we have an APU reset? An RST? Cannot find one. Nope, let's see if I find something with APU TRST. Oh, this is just the 1.8s connected to it, okay. So this doesn't matter. Chip reset, KB reset, PCIe reset, RSM, RST, yeah. None of this really matters. PCIe reset from here. Going into a 33 ohm resistor. Oh yeah, and then also just going here, okay. What was this line? PCIe reset PM. So there's no reset signal on the PCH, is it? This is being pulled low. So I had voltage on all of these but there. Okay, how does this work? U43. We need this. Have you checked the LDO? Which one? There are a lot of LDOs on this board. U43. So this goes into the PCH. Into the PCH is the output. This is an input, this is an input. VCC3 and this. Okay, why is this low then? Is this being pulled low? I want to check if this is high or not. If this output. And I might want to put that output high by myself. Pin 4 on U43. U43, and this is pin 4. We want to check that, but for that I need to take off that cooler once more off of the PCH. So let's do that. Oh. Yep, mic was lever was muted. Thank you. So I got a small heatsink onto the PCH. We now at the U gate. Let's now power this up. And I want to see what kind of values this U gate will have. If the output of that is low or high. The battery is still holding, but it did beep at me already that it's getting lower. But for now, it was just a mistake on my end. So let's see. 1.8 volts here at the reset. 3.3 volts there. 3.3 volts there. Yeah, no, this has everything. 1.8 volts and 3.3 volts. Yep, this is also outputting the reset signal for the PCH. Man, this thing gets hot quick. X570 is ridiculous how hot these PCHs get. And one more thing that I can try is assert some force onto the corners of this PCH, or like the PCH itself, just to see if anything is changing. But no, nothing is changing with that. Whew. Oh, I'm exhausted of this. Whew. Well, guys, it's been a couple of hours. I think I'm going to call it quits. Hot air. Let's do hot air. As a last resort, let's hot air it. Let's go to the overhead. We're going to hot air it and then going to try it. As the last resort for today. So let me get my hot air into here properly. Because I'm interested, like, I want to get this board fixed. And trying options like putting hot air into this is definitely something that I would also consider. Like, I have fixed boards before with this. And I want to see if this does anything different then. And I think it went into thermal protection. Yeah. Because the current went higher and higher. And pretty sure it just went into thermal protection. Because you could see the current being quite high here. 3.6 amps. And just the same behavior. So after heating up, no change for this. Sadly. Oh, it turned off? What? Huh. Okay, it just turned off by itself, but it's probably just because it's too hot. Let's reset this myself. Oh yeah, it doesn't want to turn on anymore. Did I kill something? I might have. It might just be too hot as well. But I might have blown up this PCH. Yeah, it does not want to start anymore. But it might just be too hot currently. But I might also have also killed the PCH. I do not know. Let's see. Yeah, it might be game over, but I might also be happy about that. Oh, you cannot even see. Oh man, really? Did I not show that? Ah. Yeah, I've been just going about a little bit about the hot air. We can also cool it down. Like I've talked about this before. I do have a compressor here. So now we went the other way. I hope that wasn't too loud. Sorry, everyone. Actually doesn't turn on anymore. Did I actually just completely kill it? That would be insane. That would be a first. Yeah, I've never... That has never happened to me before. Let's check resistances for, like, the regulators. Because the passive power consumption also went up on this. Is anything getting hot? Is the PCH getting hot in standby? No. Does any of the regulators get too hot? Interesting behavior of this board. Never seen this. PCH dies easily with thermal note. No, you fix it as if you now have a problem. What is your hot air temperature? Check resistance 1 volt line. Yeah, we'll check that. Let's see. Let's see for the resistance here. So I think the 1 volt line is the right one right here. No? Is it this one? Oh, I don't have my probe hooked up. Okay, not getting resistance here. What about here? 3 ohms. That seems fine. I've had 3 ohms on X570 multiple times. And the other one, how high is the other one? This one has 33 ohms. Yeah. So like, I might have gone too far with this one. Might have overdone it. Yeah, I just used my usual hot air temperature, but I was further away with like around 400 degrees. Making a keychain out of it. CPU no cooler, maybe it turned in. I don't think so. I can try a different CPU also in here. Let's try a different CPU. This is now a 3100 in here. Yeah, no change. Same behavior. For science. If you can't fix it, cook it. If you don't have short on the chips, you're fine. It's cooked. It should read as shorted. Overheating under thermal cam. So it's definitely not shorted. We won't really see anything under the thermal cam now, I think. It's weird that we do have higher power consumption than we had before, which would pretty much only lead me to believe that the PCH is shorted. Let's see here. Is anything hot? We have a little bit of heat here. Let's zoom down so you can actually see as well. The light is set to reflecting, but I cannot do really anything against that. So I'd move it a little bit different. So the 3-volt regulator is definitely getting a little bit hot, but nothing special. Like, yeah, nothing in particular. The small regulator right here getting a little bit warmer, but yeah, that shouldn't be anything. What regulator is that? The 105, yeah. The 105 has a little bit of heat, but that's like 35 degrees. That's nothing. Yeah, but I would say I probably cooked the PCH on this one. If it wasn't damaged before, I did it now. Like, maybe this is the final straw that I can finally just throw this one on my parts to my donor boards and just go on with my life. So let's see if we can see anything under the thermal cam like getting extremely hot when we try to power it on for that brief second. Let's see right here. No, nothing. Yeah, I actually, it is weird that for only that, it now doesn't turn on anymore at all. I would also want to try to turn it on in a few hours and see if anything then is different. Because I've like cooked PCHs before as well, and it really didn't change anything. It didn't behave like this. 3 ohms is very low, but X570 very often has that. Rip aim for motherboard if you think so. It might be sent to France. French fried chip. This more like broken track inside board, fully cracked because of thermal shock. It might be, yeah. Let's see for the resistances of the 24-pin adapter, because it seems to go into a protection mode like that. So let's see if anything from there is different. So 3.3 volts is shorted. Oh, heh. What a coincidence. How could that have happened, huh? What could be connected to the 3.3 volts that is shorted? Thinking emoji. Let's inject some voltage into here. Let's go for 1 volt. Let's get my probes here. So getting ground is hooked up. We have 1 volt. Let's get my pick that I always use to inject voltage. And so that the thermal camera is set up. So, whose money is on the PCH that 3.3 volts is shorted into the PCH? Where's my... there's the macro lens. So, let's see. Let's get this set up that everyone can see properly. Looking like BGA balls were shorted in PCH. No way that the BGA balls shorted in that short of time, because that was like, what, 20 seconds of hot air of 400 degrees? No way I've gotten the balls actually solidified. Three amps. Oh yeah, I think I could see. Oh yeah. Oh yeah, I cooked the PCH. Oh yeah. Cannot believe that in that short time I actually cooked the PCH. Wow. Did it really overheat from that short of the time so much that it shot the 3.3 volts inside it? That is crazy. And that is like with 1 volt of current. 1 volt of voltage. If we go a little bit higher, let's go like 2 volts, because this is a 3.3 volt line after all. Yeah, no. Same. And without the macro lens, it is the only thing that is getting hot, pretty surely. Yeah, nothing else is getting hot. Only the track of the PCH. Yeah, internal transistor cook, hot air assisted heat boost. Yeah, I probably cooked it. That was probably too much. I just sped up the process. Yeah, maybe. Ugh. But now it's even easier for me to put this on a donor pile. Like, I didn't intend for this. I am perfectly honest. Like, I've basically done the same thing. Like, there's one AM5 repair where I cooked what was it? A B650 or X670, right? It was an X670E that had two B650 chipsets, and where I cooked it way longer than this, like way longer and way more, and while it was running as well. And that only made it work. That never did anything to it. But in this case, I seem to have cooked it big time with just a little bit of time of hot air going into there. I just shorted the 3.3 volts internally from it, and one of the transistors internally blew up. Like, I've never seen this before happen like this. And now the big question will remain, was the PCH already failing? Or did I just do something completely stupid to it? Like, I cannot tell, to be honest. Let him cook, but in literal sense. Oh, yeah. I cooked. I really cooked here. Don't forget to leave without power, like plus minus shot to Evernet. Over try again. No, this has a 3.3 volt short. A 0 ohm short. This thing is cooked. Like, no leaving it overnight will help this. This is why I just reflow chipset from under the board. Maybe focus the nozzle on die. I think it was starting to fail. It might have been starting to fail, yeah. Is this sorted without the CPU pulled? Yeah, it is still short. Like, I disconnected everything from this board. And it is a full-on short, if you can read that. 0.6 ohms and even lower to ground on the 3.2 volts. Now inject 60 volts. I admit, but for a few seconds, like electronic capacitor, blow up the short. Yeah, actually just blow it out. The problem is that it's connected to the 3.3 volt line, and if I then connect a lot of voltage, I just blow up everything else as well. And I would kind of like to use some of the parts as a donor board. But it would be funny. I remember Louis Rossmann actually doing that. When he had CPU shorts on MacBooks, he actually did that sometimes. That was really funny. Great fire show. Yeah, with 12 volts injected. Ah, well then. Well, we will never know if there was anything else. What actually was buggered on this board, we will never know because I just fucked up. I just blew up the PCH. But at least it gives me peace of mind and one less board on my stack of boards that I still need to look at because yeah, with the dead PCH on this one, I'm just going to toss to the side pretty surely and just call it quits on this one. And just start to take parts from it. How are the homemade power supplies selling for you, Daniel? Do you ship to the US? I do ship to the US. And after the video of JFix, where he received one of my units, I started to get so many people to order these. Like, I only currently I have a single one in stock. Like, this is the only one I have in stock currently. I can make it takes me about 90 minutes to make a single unit if I have all of the parts. With 3D printing and everything, it takes way longer to make one. So realistically, I have time a day to make like about 2 of these. And people just started to pick them out of my shelf basically after the video of JFix. Like after they have known that this is an on-screen display for basically all power supplies, people have just started messaging me a lot about them. And yeah, people have been very happy with them. Like Paul Daniels is making his own version of an on-screen display that does the same thing, but yeah, he isn't. I think he isn't even done with that. And I have had a look. He uses a very similar chip to my one that is less accurate because he uses the INA 229, I think it is, or 226, and I'm using a 260. His one needs an external shunt, and mine one is calibrated from the factory. But my chip is also a lot more expensive to get, and he does them without a display. So his only does on-screen display, and my one comes with the additional display as well, so you don't have to use the on-screen display. And he uses micro USB, if I saw that correctly, for whatever reason, while I'm using USB-C. Yeah, so there are a lot of differences for the Paul Daniels ones and my one, even though they do the same thing at the end. It's rare a chip dies just with heat up hot air. It already had a problem previously. I would also think that it actually was a failing PCH already. Because I have heated up chips so much, I have cooked chips so much, and they never failed for that. And this is the first time where a chip just like that turned off and dead. Like, it's really weird. Like, I will take full blame on this, that I just overheated it. But it's still weird to me. Yeah, just reach out to me via email. That is the bad thing. I still haven't set up any shop or anything. I will need to get that done. Like, JFix has recommended Fourth Wall to me, and I definitely have to get that set up at some point. So it's easier for people to get a quote on that and buy one. But even now with email, I'm selling quantities of them where I'm struggling to keep up with building them. Is there any option to run motherboard without SIO? No. You have to have an SIO to run the motherboard. But I have had half failing SIOs still work. I agree that chipset was too delicate compared to others. Yeah. I just finished my repairs for the day. My last repair was shorted PCH. Guess what we have? Yeah, so it's easy to write it off as a bad PCH that was already on its way to fail. That's like just throwing out, yeah, failing PCH, that PCH. It is very easy to just call it that. But I also have no idea what other thing could have been the problem from before. So it really could have been that our PCH was on its way out and we just accelerated the process and now know what is actually dead on here. But it still could be that something else was dead before. I would want to hear from you guys. What do you guys think? Was there an actually other fault on this board? Or was it a failing chipset? I just throw it out there what you think. I just want to know what people think. Doesn't matter if you're right or wrong here. I just want to know what you guys think. Do you accept PayPal? Yes, I do accept PayPal. For knowledge purpose, check the USB data plus the data minus. In my observation, the PCH is short, USB is also shorted. We can do that. I say feeling PCH, damage, corner, and chip. Might be. Let's check. Let me see for some USB connections. If I find a short. Let's call it failed chipset and then we call it a sleep night. Yeah, I probably will go to sleep after this because my wife also waits for me for a long time now. Let me quickly see which of these is USB plus and USB minus on these headers. So that I know what to check. Here, all of these four. Yeah, these four to check. Let me see. So we have ground and we have these ones. No short on USB. No short on the USB headers. So the USB headers are fine. There's no short for these data lines. And the fuse also doesn't seem, the 5 volts, yeah, that also doesn't have a short. So no, we don't have shorts on there. USB port, not connector. We can also do that. Let me quickly see. Let me get... Let me see. The two inner pins are the data lines, right? But no. I don't seem to get a connection to ground. Complete outer one is ground. But checking data plus and data minus, they have high resistance in the USB ports. Checking other USB ports, and I get low resistance on the ground pad. Yep. So not that. Pin to pin. Let's see, can I do this with my probes here? Do I have my second needle probe here anywhere? No, pin to pin from the lower side also not shorted. Who knows, is there a chip problematic one? PCH with other similar issues, then yes, but seems more problem with Ryzen CPUs, PCH chipsets even going back. I think I've never had a dead one. Yep. Use compressor again to the chip to measure again. Tried to replace PCH on an HVC using preheater. It turns on before it wasn't turning on at all, but now has some will not allow to boot up parameter. Yes, pin to pin. So I'm calling it quits. That PCH is dead. I will take the blame for this. I think I overheated it too much. And I will call it that. And that there was an other underlying issue that I have not found, sadly. And we will never know because I'm not going to replace this PCH when I know that there's other different faults with this. So yeah, I hope you still enjoyed this repair. Thank you very much for being here while going to 10,000 subscribers. So thank you very much for that. Cannot tell you how grateful I am and thankful for that. Is there any values of broken motherboard? This has a lot of value for me for the components, so I will take that. Thank you for streaming. Thank you very much for all being here. I think, let me check. How long have you been online? Like almost 5 hours? 4 hours, 40 minutes. That is by far my longest stream so far. And I thoroughly enjoyed it. I thank you all for your suggestions, for your opinions, for talking to me, for being with me. Thank you so much. And yeah, so everyone, take care. Have a great night or morning or whatever time it is for you. And take care. We will see each other, if not in another live stream, then definitely on Saturday with yet another video where we fix a motherboard. That video is already prepared, so yeah. Let me see how to end the stream now. So I'm definitely offline. There it is. Bye, guys.